Hello everybody, here we are Monday evening, Monday the 17th of July, and we're back again. So I hope everybody's doing really well in the chat room, and today we have Chris from Canada, we have Ceres from Holland, Patricia UK, and me UK. And just before we came on air, Chris was talking, so you may as well just carry on talking, Chris.
Yeah, so I just explaining the comparing notes here with Ceres on the development of the maps and stuff. So what we have is if I zoom out a little bit, up on the left-hand screen, so I got the screen split into four so we can see, but this is all just one model. It's all the one model in one shot, but I split it into four different views. So we have basically this is the toroidal flower. It creates the flower of life in the mandala. And if I zoom way, way into the center, so it's just torus inside of torus inside of torus until we get on the z-axis, which would be north-south. Way, way in. So this would be the map on the north-south axis right there. And then we have the camera. I'll zoom out just a little bit. And I can show you where the camera angle is. So the camera is angled following that torus. It's slightly off because that's where the moon's going to be in this particular. So the camera would be looking on the east-west line, but pointing straight up at high noon. And in the other torus, we have, if I zoom in, that's where the moon follows that torus field, magnetic field. So that's the basic setup. And over here in the right-hand side, which is what you would see at the equator, because the camera is dead on the equator, at high noon is a high noon half moon. Down in the right-hand side, I just have it set up so you can, this is all the way zoomed out. So you can see that there's a crystal in there, basically is what it's looking like. Oops, what did I do now? Get that back up. Okay. If I go to wireframe, just for a second. You can't really see it very, very well, but if I go cube, it's a cube actually. So there's a cube in the center, which is like a diamond. It creates like a refractory diamond. So all it is a cube with the corners knocked off, and it's set up to be an anastrophic field that lets light go in one direction only. So which would be time. Light travels through time in a singular direction. Although it's everywhere in that realm, it goes in one direction, then bounces back, and we see it to our perspective, always going back to the source of the light, which is kind of a far out thought, but that's how it's actually working. It's the only way to get it to work. Because if you make a sun object and then cast the light in all directions, well, then it just saturates everything, and you can't get the shadows to work properly, and none of that will work at all. So if I render that again, and then I go over to the bottom right-hand side where the flower of life here, the toroid makes a perfect 24-hour clock, and it's a crystal clock pretty much. And if I pick the sun and then rotate it on the y-axis backwards, and you just keep an eye on the top side where the moon is in that image. I'll try and rotate it slowly and give it some time to render. So if I go to, say, underneath, slightly, you get a full moon. And then at say the 6 p.m., 6 o'clock mark, that would be a new moon. So the moon isn't visible until it starts to come around again.
Mm.
Of course, I can take those. It's probably better if I take those toruses off. It'll be clearer. So the toruses just mark out the magnetic fields, so I know where to position the planets. And let me just see here. I got them all turned off.
Too much lines.
Yeah, I'm going to take them off. Yeah, because there's too many. You get too many lines in it, right? And the moon Taurus.
That's
There's
why
now
drawing it to
Yeah.
the slice through is way easier.
There. So now all we have left is the crystal, basically the crystal clock, and the moon and the camera and the atmosphere that we're looking through. So now I'm going to rotate that. It should render a little quicker too, probably. And the sun, we want the sun selected and rotate Y. So what's interesting is if you watch the as the moon goes through its phases, you can see the crystal down on the left-hand side change its color until it gets to almost perfect 90 degrees, which is a half moon in daylight that we would see from the ground through the camera. And then the crystal is glowing white, perfectly white. And that's because the light, like I said, the light is going, it's anisotropic light, so it goes in one direction and bounces back. And you can see in the right-hand side that stars will start to appear automatically.
Mm.
Right.
Sorry, no, we haven't seen this either, have we, series? Because we had a couple of days off. We didn't come on, obviously, because it's been a very full-on every night on Hangout. We took a couple of days off. And even we haven't seen Chris's work. So, carry on, Chris.
This is just to give you guys an update. So that's how it's the sun follows the Taurus, the moon's following the Taurus, they're all following that path, and then you can basically walk right through every phase of the moon. So this is your crescent moon as it goes around from the 12 noon to 6 going backwards. Right, and then it just shifts when it comes around the other side, and it starts going the other way into the gibbous. So there's all the phases of the moon right there. It's just like clockwork. But it's complex, but it's simple. It's at the same time. I find it's just the precision just blew my mind when I saw it. Right.
Yeah.
Right, and it's based on the Taurus fields. So you can see there's not much in it for parts. I mean, all it is the map, the atmosphere, the moon and the sun, and you just follow the Tauruses. Right, you follow that pattern. So that means that we're looking at the sun and the moon and everything actually in sidereal, what they call it's be called sidereal. We have to kind of envision that we're standing essentially on the plane looking out sideways, and everything's going around us or over our heads, right? It's following that Taurus in a sidereal fashion.
As an eye lens.
Yeah, exactly. It's a lens to an eye, basically. Yeah, it's a perfect lens. Yeah.
You're always in the middle of that lens.
So to save some time here, I want to see if I can. I'll stop screen sharing just for a second.
It's like we are our own toroid fields within the whole light spectrum of in the realm that the construct itself. We are the toroidal field, catching the circle around us as the lens.
That's exactly it. Yeah, everything comes back to the center of our perspective. Now I had some pictures. I'm going to see if I can find them here. Okay, so we're done screen sharing. That's good. Minimize that one.
Chris, or are you going to change the picture? Does
Yeah,
that mean, when we were talking just before you came on, so is the shadow of the moon, is that always us making that shadow then? Or just in eclipses?
No.
It's it'd be the sun. The sun casting, the shadow of the moon is on itself, been made by the sun, right? The sun's shining on it like a ball and just going around it. And then when it does eclipse, it's the moon is between the sun and our perspective. And then a lunar eclipse, though, I think is completely different. I think that because it never really goes black, right? So if it was us casting the shadow on the moon, then obviously the moon would go completely black and disappear. That does seem to happen during a new moon, but not during a lunar eclipse. I think the lunar eclipse is caused by the shadow of Venus being projected onto the moon, and it goes red. It goes like a red hue, but doesn't completely disappear.
I was going to say that I was going to be a bit upset if after all it was us that had left the shadow after saying for so long it wasn't us. Yeah, I was just checking there, but I was just checking.
Yeah, it's a bit of both. Yeah, we do it, and also the Venus does the eclipse for the lunar eclipse. Near as I can tell, anyway, when you rotate the sun around our center, because it's geocentric to us, right? So we're on the plane and everything goes around us, right? So I was going to try and bring up, if I can find them now.
I think both you and Series have been busy this week doing things, haven't you, Series? I know that Series wants to show some of his soon. But that's what you've been doing at the weekend. It's always masses of work, Chris. Thank you very much for everything you do.
Yeah, I've been hard at it this weekend, yeah, for sure.
It's hard not to, I think, once you understand something maybe and you get your teeth into it.
I didn't have these pictures separated. I should have separated them, but I'll do it in a separate application here. It's just a Facebook post I made. I'll show you these, and then Series can go through.
Okay, I'm just presenting you again.
Get this to work properly. So these ones take a lot to render, but that's why I'm not going to bother trying to do it live, because it takes a long time. So if you take the camera from the little spot where I showed it positioned and take it on the Z axis and actually come outside of our atmosphere, right, way up top, and look backwards at what I'm actually shining the camera through. So when we're looking up, what we're seeing is the sun appearing on this level. So no matter where you look, that's where you'll see the sun, right? If you're down on the flat map underneath here looking up, then you'll see the sun at this perspective. If you're in the north, you look this way. And the moon is being projected into it also. So this is like the eye lens that Series was saying. And this would be the red layer of our refracting atmosphere. This would be the blue, and then the green. So mix the iris of the lens. So everything we see is within our visual perspective. And this is actually a solid model, right? So it's a three-dimensional solid model, and the camera is inside looking out in that, what I just showed you. The model actually kind of looks like this, right? It's a square with the flat map. So then when you move the moon, so when I look through it on the angle in an orthographic view, you'll see the moon appear right inside of it, right? So then the camera's just looking at the image inside of it. So and that reminds me of the ancient map, right? With the handbags, with the handle and the shoal underneath and everything. So this is actually what's constructed the 4 pillars, right? It's all in there.
I think people get a bit confused when we say, like, we're researching square flat earth and all these circles turn up. Can you just explain again? I know you have, but what that circle is, Chris? Like what it is, because they're going to see
this here.
Flat, like flat land, and then there's a circle in it. Explain.
Yeah,
it.
this is.
Yeah, explain it again. What that really is.
Yeah, so this is the square flat map at this section here. on the what would be the considered the 4 pillars. And this circle here is just the atmosphere, because the atmosphere is curved because it's under pressure. So we have atmospheric pressure, which creates a bubble above our heads, right? The atmosphere is curved. The atmosphere plane actually curves over the plane, but it has an arc to it. Or some people might call it the vault of heaven. Some people call it that, right? The vault of heaven, or the heavens above, the firmament, right? It can be called the firmament, but it has a curved arch. And the blue is the air, which is under pressure. So when we look, if we're standing on this flat map here where my finger is looking out through the camera, we would be zooming in on the image of the moon. And you can see how when the moon's actually refracting through the lens, it gets huge. But actually, it's just this little tiny image up here that we're standing here on the ground, looking up through. That's what's happening in the model. So through the camera's lens, this is what we see. This is the 2 images I grabbed of the moon, one during the day and one during the night. And you can hardly tell the difference between that and that photograph. And all it is just a ball that's covered with the map of the moon, and we're looking up through the camera. So this model, there's nothing, so far I've been playing with it for 2 or 3 days now, and there's not an image that I can't, reasonably replicate through this simple setup. This would be the camera looking on the flat map, looking, I think, east, or no, west, I guess. It'd be, no, east. So this is east just before the sun comes up, and this would be the moon. And what happens is, just before the sun rises, it'll automatically generate this morning star. And what that actually is the sunlight refracting to almost to a point of infinity. So that is actually the sun just before it flashes and rises in the east. You'll see the morning star, and the morning star will drop as the sun rises in the model.
Oh.
Right. So I didn't paint that in there. That's not an object. It's just a reflection, a refracting effect.
Is that what some of the stars is that what some of the stars are then? Or just that one?
No, I would think so. I think most of the stars, not most, but I'm not sure exactly how many, but a lot of them would just be refracting light that's reflecting on itself within the medium we would call space. Right? But it has to have a medium. There's a medium there in order for the light to appear. So stop sharing. There we go.
Yeah, from the outside looking in, it's a whole other way to look at it.
It's a whole other way to think about it, yeah. And there's one more thing I wanted to show you here just before, if I can bring it up. It's along the same lines. If I turn that one off. I'm starting to get the hang of this Hangout thing now. I'm getting pretty a little quicker at the screen sharing. And
yeah, it sometimes doesn't work properly, does it? It's a bit annoying when it does that.
So what's happening? So now things are starting to tie together, right, with the ancient stuff. And I know where a lot of those images were coming from. Ceres and I were having this conversation before we came online earlier. Was that the lens that we saw with the moon and the sun projected into it, it's essentially shaped like this. And what happens is the light refracts to the center point, which looks like an eye. You can actually see a tiny little eye in there. And I also see why nature would tend to want to build things like spiders and ants and stuff like that, right? Because you can see that when I compare this image here and the circles that appear in it through the refraction of it in a wire frame, it's almost a perfect image of a scarab beetle. And these aren't painted gold. I mean, they're that color. They are that color naturally, green and gold. And it's actually a metal. They have a metal oxide on them, or metal halide type of coating in their shell that helps them both reflect the heat, keeps it from cooking, but allows them to collect enough energy to So it's amazing how they're perfectly formed to reflect the light from all directions in 360 degrees, which makes sense why, Egyptian culture would have come up with this idea as well. It's profound once you get into it. So then Sirius and I started working on the map, taking the GPS and then the flower of life from the center point and mapped that to the north and south poles. And so the first toroid is the width of 12,742 kilometers. Then you just build the next one on the next one. And when you rotate them to match the magnetic fields where they focus, you end up with this type of structure, which is now stackable, and it has a crystal in the center, a natural crystal form or a diamond shape, which is where I got the idea for the refracting outer sun layer. Everything reflects the back light. So light within a crystal can only go in this crystal can only go in one direction, and we're dead center. So what works for the model of the universe essentially works for an atom. It's like a model of an atom or DNA. If you link them up, well, there's crystal DNA, carbon atoms, and it's all in there. So it makes sense why some of the older cultures would have come up with this type of idea, the flower and the DNA. And I don't know whether they knew about DNA back then. I'm not sure, but it's certainly profound coincidence, right? There's a screenshot just to show the setup again. So
it's amazing that they knew it all then, isn't it, really? And we're only uncovering it all now, but they knew it all.
They seem to have known it, yeah. Intrinsically, somehow, yeah. What I found, here's some great pictures from this fellow's on my Facebook friends. I give credit for his images. Is Anderson Neves, I think is his last name. Neves or Neves, from Sao Paulo, Brazil. He just posted these, and he's showing. He's got all his parameters there, the date and time, UTC, and there's the sunspot. And over 6 hours, he took a shot, and you can watch the sunspot travel.
Yeah. Wow, pretty fast.
Right, so that's 6 hours of travel. Right, so that right in itself tells me that shadow is probably, since it's 6 hours of travel with the sun relative to his vantage point with the camera.
Quarter.
Right, it's traveled a quarter of the entire sun's distance, right? So that tells me within reasonable doubt that spot is actually our shadow on the sun itself. As the sun goes around the toroid, this spot, and you can see it's actually a little crosshair. It's like,
really? That's us.
yeah, it looks like it's a dark spot with four corners. And I thought, I was trying to zoom in on it.
Really?
To get a decent shot of it. Right? It's pixelated, but you can see it's like a little figure 8 type of thing with four corners in every picture. It's the same. Right? It's a little spot with a cross hex, four corners. But it travels that's a quarter of or almost half the sun in 6 hours, which would be about
not
right.
all spots are that particular one.
Yeah. So the sun, the angle to that shadow has to be relative to the observer. So if the sun travels, he's taking pictures for 6 hours, and that shadow's traveled almost half the sun, which would be half a day. So so either one of two things: either the sun is spinning that fast.
6 hours is a quarter. You see only a quarter turn.
Right. So there's where he starts, and this is the last. So there's a quarter turn in 6 hours, because we go from the time of from 9:30 until 14:30, so that's 6 hours, right? And it's a quarter turn. So that pretty much tells me that that shadow is our shadow on the sun as it passes overhead. I can't think of any other explanation for it. So the light comes from the sun, bounces off of behind wherever we are positioned, and then makes a cone shape and reflects backwards to the source of the sun. Otherwise, the sunlight would just, be blinding. It would just fry everything. So it has a chance. It seems to have a chance to go out and then cool off and then come back somehow. I don't know how, but that seems to be what's going on.
The same way that the shadow is actually causing its own shadow, that the sun is actually causing its own shadow on the earth.
Correct. Precisely, yeah. Yeah, so if what we see is nighttime, right, is actually the shadow of the sun. We're in the shadow of the sun. It's really hard to think about, but it's backwards, right? The light goes out and comes back. So what we perceive as night, and in actual fact, we'd be looking dead center into the sun, right? At nighttime at 12 midnight, technically we're looking directly into the sun, but we can't see it because we're in the sun's shadow that's coming backwards.
So
it's really hard, and it took me hours to figure out how to
big
the cameras. The sun?
Well, it's the other toroidal field, of course, in a sense.
Yeah, it is toroidal field. Yeah.
In that you have the light part in where you have the fall down, and then the dark part in where it goes up, for actually the shadow of the light.
Yeah, I'll try to get in the model there in some different angles. It's really hard to get the shadow to show up because it's all black. Yeah, I can get it positioned just in a certain way, and I can sort of show the shadows. I'll stop sharing there.
So how big roughly is this sun then?
I have no idea. It'd be huge, right? I don't know. I have no idea.
So the only reason we get a night, the sun coming back.
I'll try and.
Oh my goodness, you learn something new every day.
Yeah, it's hard to explain. I got one picture here that might kind of
explain. It's the other way around. Is that what you're saying? It's the opposite to what you think it is, how it happened?
It's completely backwards, yeah. I'll try to open this one, maybe. I got one picture that I was able to grab from outside of the model here. So essentially, this should be where we are in our refracting lens. And this is the moon we were looking at before. And you can kind of see up where the sun image is, there's a cone, a black cone that's coming from here all the way back to the sun. So the sunlight goes past us and comes backwards, and we're looking towards the moon in the night. So the night is actually in this half of the dome lens, and the shadow is going all the way back to create the spot on the moon or on the sun. So during the daytime, this would be reversed, right? So this would be a kind of a nighttime shot, I guess. But there's the shadow cone right there, about what is that? 7 or 8 o'clock at 8 o'clock on the clock. There's the shadow being cast backwards. It's the most profound thing. I mean, it took me hours to figure. I thought I did something wrong. I couldn't figure out why I couldn't see the moon. I pointed at the moon and I couldn't see the moon. Right? I had to start doing everything in reverse to make it work. Yeah.
Does this explain where the moon goes for a few days where we don't see it?
That's correct. Yeah, when the sun is down underneath, and then for 3 days it goes dark. There's a new moon, and then so it's I think it's 3 days. but it works. That's the way it works. Yeah.
Sometimes it's longer for some. It might be up to 7 days or something.
Yeah, there's a new moon. Yeah, it depends on the angle. So
The moon from the inside out. That you have the shadow side, what from the moon is actually towards the sun.
Yeah.
That the sun's energy is going through the moon and light it up from the inside out.
That's correct. Yeah. It's the shadows on the back side because you can kind of see the moon shadow going towards the sun as well. So the light comes this way first and then goes back. So we see this face all the time, and then the dark side of the moon would actually be facing the sun.
Yeah.
But it creates its own shadow going back to the source, like a vortex of energy. Just it's hard to explain, but that's what's happening. So you would end up with a short, because of the height difference here. Yeah. So you'd have like a short new moon and then a longer new moon, depending on the angle of how big the shadow is cast. So short, if you have a 3-day new moon or a 7-day full new moon, depends on where the sun is positioned relative to this shape. So it definitely seems to be an ellipsoidal type of shape with a flat center map in the middle. This here I just put in, it's just to help me situate when I'm trying to, it's pink though, it's just pink. Yeah. That's like a foundation type thing. So that's just for me to help me position, because it's hard to see inside the model. I can't see anything in there. But when I go outside of it, because if I turn this 1 degree, then the whole screen goes black. And I was like, what happened? Right? It's because the light is only going in one direction. So if I turn it just a degree or two, it no longer reflects. Yeah. Strange, eh? But it works.
Now, what do you make of that, please?
Well, so far much of this stuff goes way beyond my understanding, but all that particular physics stuff, what goes behind this, I've just never learned it. But I can see how this whole toroidal field stuff works through the flower of life I discovered as well. The grid of the flower of life is actually forming the toroidal field.
That's right. Yeah. Yeah, if you look at it from the top down, it's the flower of life pattern that you have on all of your two-dimensional layouts. Yeah, it's exactly the same. Then when you just turn it into a 3D object and look at it from the side, it becomes the torus. Yeah.
So with all this flower of life and everything, the way it's all situated in these toroids, it completely sort of puts space out, doesn't it then? I mean, even if you thought it was there, it can't be there because of the flower of life and everything.
It seems. Because you actually end up within the field itself. It is always the toroid where you're stuck in that sense.
Yeah, as far as getting out into, if you went out in beyond the lens realm, which protects us, you'd end up in just nothing but plasma. I see it as a pure plasma type of environment. It would be just hot, 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 and then cold, 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 and then hot, then cold. It's interesting, the very thing that keeps us alive and protects us is also impenetrably dangerous and deadly, right? It burns up all the meteors or whatever else might be heading in this direction before they get here. At the same time, I think from a physics perspective, the energy coming in is driving the plate tectonics, and so Earth realm itself is actually expanding over time, because all the cracks between all the continents are being filled in, right? So all of that matter and energy is coming from somewhere outside, right? I mean, Earth is growing, all the continents can't be moving away from each other without creating giant voids in between them. So it's being filled in with, more matter and pushed apart more matter. So it's coming from somewhere, and it certainly isn't falling on our heads. It's not falling in and then, being ground up and driven back to the surface. So I see it as plasma energy coming in through the magnetic field, being converted into matter itself, and then into a gas conversion of some kind, which converts that into water and solids and elements. And as it cools, salt and so forth can transition, like a transition metal turns to, creates earth. It's a self-creating type of thing. So the particles can come in very small form into the center of the flower of life you have there on the screen, and then expand outward.
So in a way, actually, the square is growing.
The square is growing, yeah. Yeah, you can almost see, like in that diagram there, you can almost see where, approximately, the continents could be, right? And then the whole thing is just expanding outward and growing. And to make it work, like I said, I had to make a cube on the outside, and then make that into knock the corners off like a diamond shape. Then the light all focuses in the right direction, back to the sun. No matter where it is, right? It all goes back to the sun. Because inside the diamond, it doesn't matter where you put the sun. Like I could throw the sun in a corner somewhere, and it'll still all the shadows go back to the sun. Always, because in a perfect diamond, right? All the light goes to the center. Now that's the holy grail of jewelry, right? The perfect diamond, right?
Yeah, that's
jubilee.
Self. Yeah.
Yeah.
Sorry, Series, you were presenting something which I just took you off while Chris was talking. So do you want to explain what your pitch is about then?
Well, so far I'm working with the triple square of the Earth map, and this is how the flower of life actually fits in on the triple square. And the bigger circle is the toroidal field, size of the toroidal field, what has a reflection through the spatial loop, what actually crosses the flower of life points as well. And this is probably how the toroidal chain works in the fields, that the middle square is our realm, and then to the right is north with Mount Meru probably, and the south to the left. No idea what to find there, because the particular pattern actually begins with a particular wave. Not sure how that actually works, but it could be other side of the energy, that north is the magnetic mountain, and then south is the wave pattern. As two opposites between the earth. And that builds actually up from every side probably, in that there is a particular balance, in that every side has a particular opposite function to make that balance in the middle, in where we are. And you can see the eye in there as the interference pattern of the several toroid fields chained into each other. And then the side circles are the particular chain position and where the pillars are. The 4 pillars of the earth are in the middle of the circle, but in the north and in the south you have 4 pillars as well. And the next realm circle is actually tying in our inner pillars, but our toroid field is tying in their inner pillars. And so we have this particular connection between the two toroid fields where you see a particular extra up and down circle, and where the middle of the flower actually has the strongest line up with the bigger toroid fields. Yeah, I just have drawn this. This is probably how we have to line it up within the whole construct of the square the same. I figured on it that we have a little bit this position in 90 degrees, minus 90 degrees latitude and 1.5 degrees longitude and 1.5 degrees latitude to line up with the sun analemma. What causes that it actually lines up in the south with the pillars at the edge of Antarctica, and then completely at the end edge. It lines up with the middle of the wave of in the south, and actually at the edge of the wave. And from there we build up the whole tree of life within the bigger toroid circle. The bigger toroid is the tree of life pattern in that sense. Of course, is the tree of life pattern within the triple circles, the little circles. Yeah, it's a combination of toroid fields and flower of life and the sacred geometry, basically. You can position anything throughout nature through this. I'm just amazed about actually realizing that the square does grow in a way, but then it has to grow in spatial sense as well. So I'm figuring if it's not there, I just don't know. We have to look at the elevation data itself. It seems to me like there is a bigger wave function between the pillars, because there is something happening in the elevation there. One is the lower of a land and the high mountain in sea, and that part shows, so there's a certain dynamic at work there that I wonder what that actually is. And it's between both pillars. It's, yeah, I figure we would more need to look at it to actually get more ideas of what it probably points to.
Kind of what I figured is nature had to figure out a way to solve for time and light. Like if light was omnipresent in all directions, so you have to divide the light from the darkness, and the only way to do that is to give it a direction, and that means time. So light and time are connected somehow. Like that's why the shadows go back to the source. I think that's the only thing I can think. It's profound, and I don't know exactly how it works, but I think that's kind of the direction we're headed in. If that makes any sense to anybody at all.
Yeah, you're talking about a perfect diamond, and I guess that is the particular construct of how the flower of life builds up to the diamond structure, which you see in the triangles when you line up the crossing points of the life. That builds the actual diamond. So it's a combination of the squares and the circles. Earth is the square, heaven is the circle. And in between there we have the triangles. And those are the diamonds. They're crystals. Everything as a construct between the two.
Diamond in the sky, yeah.
Yeah. So how the hell do you explain this?
I have no idea how to explain it. All I know is that that's what the data leads to. If you construct the magnetic fields following the map from the center and it works out. That's what you end up with, is a toroidal diamond construct of some kind. Self-relative to the center of light in time. Very strange. String theory is what it kind of is. It reminds me of string theory, like Einstein and Maxwell's equations lead to string theory, which, like we were trying to do, is to, one just leads into the next, like string theory of infinite universes or infinite points of perspective on a plane of reality, one leading to the next, and each is stable and connected, but individual at the same time.
Yeah, I'm also that particular stuff with the irrationality. The Mandelbrot set, for example, because the buildup of that is based on the irrational numbers. And what I don't understand is that God itself is the most irrational what you can imagine, and we are the rational side of it. And there it gets confusing because we're trying to rationalize the irrational. It's kind of taking the root of -1. Well, that doesn't work. You get an error. But there are ways to actually work with that in computers and such. But then really understanding this, I have no idea why it works or something, and why we get this particular Mandelbrot pattern as a finite infinity within the numbers between -1 and 2. So strange is. And what you created through the circle, with the reflection of the circle, what actually created the bottom side of the Mandelbrot. Of how you actually have then in the Mandelbrot even the circles on top building up, and that part is also in the numbers, but we don't see that part within the reflection of the light or the focal point of the light. Where's everybody going?
I'm here. Oh, we've lost Patricia.
Yeah.
No, I'm listening, and yeah, I'm trying to wrap my head around it.
Really? I bet you there's a few more doing that tonight as well. So, series, I think Chris kind of used some of your pictures, but you've been putting some pictures out on Facebook this weekend. You're going to show us those ones then?
Oh, actually, let's just open the animator. Takes a moment to load. Well, this is so far, I figure there is what builds up in the middle, the Earth, and then in the left and the right, the heaven circle. And it's probably 2 halves of a snake, in how you can actually build it up as a snake, what goes up. So the right side bends up, and then the left side bends down in that sense, in ascending and descending direction. Yeah. This is how I found. The side circles you see are needed to actually build the inner circle within the square as a reflection, so you can actually see what's within there. And I'm trying to figure out how to, instead of draw extra circles outside, actually reflect the lines through the spatial construct of the square itself. And
And we've never seen those things before series. You and Chris' pictures tonight, quite amazing. It's pretty about to present because it's come on me.
yeah, I tried this to draw in the
Hang on, Siri. That's it. Cool, it's back.
three-dimensional side of the flower of life. What is tied into this toroidal structure. And the toroid fields are actually based on 3 of the circles of the flower of life. And then in north-south direction, in where you have the shorter distance of the triangles. So, does anyone even understand this? It's practically the what is it? Six-sided, six-pointed diamond of like a form. What builds is what is built through 6 triangles, and upstanding direction from the middle to the middle to the base of the middle of the base is that particular distance you have, which you need 6 times to build up the whole toroidal field. And that's within there, between north and south, you have actually the tree of life built up.
Sirius is so close to the truth that it's scary. Let's not make the earth flat, sorry.
No, the photograph makes it flat. Reality makes it flat.
And,
It doesn't make the ball any way.
but this discovery is all this that you're saying.
Michelle, we're live and 50 people are watching in.
Good. It's really the truth.
Yeah.
So.
Why not? But anyway,
Good. Oh, I got that.
That series.
and kijk where you have the colors. 119. Oh. En dan 8. En dan load. Oh yeah.
Series in the chat room. Can you just explain again what we're looking at?
The combination of the elevation data, what is the flat data in XY sense from top down, and then colors in how translated in how high they are, the positions, and then within all through there I draw in yellow the floral life bubbles and circles. And then in pink, the bigger circles, Yeah, it's loading, so it's slow. All right. Where
They wanted to understand what all that is. That's the flower of life, the tree of life, toroidal fields.
It's all tied in one drawing, so it's a little bit hard to oversee what's happening here, and that's a bit the difficulty with drawing this. There are several things working together, and when you show them all, you just can't see anything anymore. So this is as well the triple square of the Earth. Together with the flower of life bubbles, together with the toroidal field bubbles, and and everything outside left and right of the map is actually added, drawn, so that it actually could reflect through the spatial construct of the square, what goes out east comes in west, and what goes out west comes in east. But I have to draw these actually extra fields outside the middle square to actually see the lines, what are the echoes in the spatial construct of all these fields. And I'm trying to figure out how I can actually draw a bubble so that it will echo within the square itself without drawing the outside fields.
With what Chris was showing us tonight, is that some of Chris's work in there mixed in with yours now? Is it the other, and it's the other way around for him? He's got his work and your work's mixed in with his now.
Yeah, we're trying to figure out how to actually balance the particular the real measurements in that sense of the distances. How do you put this particular crystal, for example, at the position that everything lines up, that it works? And then you have that particular crystal what is working through the space loop exactly the same. But yeah, the space loop is the hardest thing because it's not 3D, it's 4D in that sense. And there's nothing actually built in a 3D engine to make things 4D. Other than, yeah, with light bending, for example, the light part is what can actually work through that. But it's hard to figure out how to make it all in the 3D engine. This is the bigger picture, and yeah, it's not a perspective we are used to. But the bigger picture is actually the sort of how everything, the big scale is. And also in smaller scale, it seems that it's what is up is down, etc. So up is so above, so below in the construct in that sense, with all the circles and the squares and the triangles. And yeah, the data actually so far gives all this suggestion that the whole sacred geometry is completely connected into this. And the only thing I'm trying is actually how to look at it in three-dimensional sense. While it is actually a kind of hyperdimensional, as in a hypercube. And the only way I can actually completely draw it in higher realms, I can actually only draw it by closing the circles, in the sense that I need a kind of 8-figure slice through from east to west of the map. And then you have the downwards, what is it, donut, and then the upwards donut, with Earth again in the center. From there you build up the next level of the fruit of life, with that particular sign as well. With the two circles, what becomes an infinity circle again, what builds up the.
Is that what Chris is showing, series? I've just put it up for a second. Is that what Chris is showing, like the infinity bit of it? Do you see?
I see.
I'm trying. Yeah, it's so I'm trying to combine series diagrams here in a three-dimensional model. So if you zoom all the way into the center and work your way back out.
Yeah, we have an interference of an east-west direction of another level of energy. That's probably why we have an east-west looping, and why the everything turns in that direction. of why time flows in the sense that the space of the, what is it, the one directional part of light. Why do you need time? What actual property of time? Yeah, the linear property of it, of course.
Yeah, it's a
Wow, look at
see, it
that.
depends on how, it depends on how you look at it. I can do it from a orthographic top down. Try and view it from the top.
But that's a bit like what you see on the sun, sort of thing.
You should place the Earth against it and see actually what a double field does in the reflection of the space.
Trying to hide. I was going to try and hide some of these because there's so many in there, but
Yeah, that's kind of placing three next to each other. That's what I do. You don't need more to actually see what is happening within the middle part.
that's not too bad there. I don't think that's. So you can see how it's the same diagram. So you can see the flower life in the wire frame and the crystal, and if you turn it right, then it becomes the perpetual on the side here. I'll get rid of that one. Actually, if I undo that, I can actually show you something there.
Yeah, if you place just three next to each other, then you actually see what the echo is.
If I can find the right one here. Right. So if I zoom in on, I was trying to explain that to you there. We were chatting back and forth. What I was seeing, you would seen the same thing in your model when you were doing the diagrams. So if you take one of the GPS maps and you lay it over the top of the other one, and you line them up, you can see that it's a repeat type of thing. Right?
Like you're selecting a color or something.
Yeah, I'm just turning one off and turning one on. That's how I lined up the distances to lay in the next set of toroids, was lining up the pole kind of thing. Yeah.
No. South should fall in south.
So
You need the realm distance.
Flip that over. Yeah.
Yeah,
The distance should be okay. I just got to probably rotate that, like rotate them. You know what I mean? So south goes into morphs into south, and then north to north.
yeah, I have it a bit closer to each other because then probably the crystals are lining up to each other.
Yeah. But then you look, if you zoom it from this side, which would be what? Is that the front or the left?
Is this all about the light as well? How the light works? And can you explain that again a bit about the bit you saw on the sun for people maybe who've just joined the chat room about how light actually works and what the shadows are? Because if there's any new people in the chat room, they might be a bit shocked. Sorry, Chris.
Yeah, I can go back and maybe try and reopen that.
Okay, then. In a moment, then.
Yeah. Yeah, what happens is basically the sun, the light coming from the sun is anisotropic, so it goes in one direction and then reflects backwards to our observation point. So what we see, in essence, is in reverse. We're only seeing the shadows, and we're seeing the shadows in one direction of light coming towards us. So wherever you look is what you see, kind of thing. And the shadows from Earth and the moon and everything else goes back to the sun. It's hard to explain, but it's in reverse.
Yeah, Yes.
Trees grow the same way, which is interesting. They're an anisotropic. A tree is an anisotropic construct. It grows from the outside in, which makes perfect sense to me, right?
I thought about that before.
That's how it, that's yeah. So that's profound, right? That's what I mean by all this stuff is so profound, because the way the light works is the way a tree works. So it always grows from the outside in, underneath the bark, and then the tree is bigger from the outside in.
Yeah.
Right. Whereas everything else normally grows from the inside out, but a tree grows from the outside in, and that's the way the light's working. The light's shining from the outside in to the center point, and because it would saturate everything, so you couldn't see anything. So the problem has been solved by making light in one direction. It's linear in that function, so that it goes beyond the object and reflects back to it. Otherwise, you couldn't see anything. It would either be pure darkness or
pure light.
Is this something that you've known for a long time, or is it something you've got to understand more lately because you're researching?
It's just lately. Well, it's just lately trying to come up with a model that works and can replicate everything properly. So as I try to solve the problems, with each problem I try to solve. Yeah.
You've been working from this sort of stars down, and Ceres is working from the land up.
Yeah.
Yeah.
Kind of.
Just you're doing slightly different fields, and you've come together now because both your work sort of intertwines into each other.
It does, yeah. I guess that's the way with everything, right? It all meets in the middle somewhere, right? For sure. Try to open this model up here again. I think this is the one I had open.
Yeah, because I say me and Ceres haven't seen Chris's drawings. Well, Ceres might have seen them, and I've not. Ceres showed me some of his yesterday, and he put them on the group. We've got to remember everything's hyperdimensional, haven't we?
It seems where the magnetic fields converge and diverge. So if there's an interference between two magnetic fields, it creates like a standing wave, and within that bubble, from point to point, is where matter and energy and particles can collect. And then if there's enough energy in it, then light will collect there as well. And then the light, of course, adds heat and its energy going into the little spaces. So it's the voids is where the action really is. And then when things slow down, at the perimeters of the bubbles is where we get matter manifesting as tangible.
So is the top of it a sort of pyramid shape?
It's like a diamond. It's the outside is like a diamond. So if I zoom out there, I'm not sure what you guys are seeing on your end. I can pop that up.
The single screen.
So you can see the left-hand bottom side with the flower of life spinning around there. Okay. So this is an anisotropic diamond. So essentially this diamond shape is space itself in the model. And I had to make it that way so that it's just a medium for light to travel in, because if you don't have a medium, then you don't get any light traveling anywhere. It just goes everywhere. And then if I render that,
Wow.
then you can see that as I spin it, it's the diamond crystal light. So you kind of think of it as the crystals in a TV screen, like the little tiny crystals in a TV screen do the same thing. They let light go in one direction, so that when you activate it with an electric field, then if I rotate the sun, we should at some point see that it'll actually turn color, right? So that tells me that the sunlight is now pointing at an angle that makes that flash. So if I turn it fast enough, it would actually, from the outside looking in, we would look like a pulsar star in space, right? It'd be rotate Y, right? It would just be a beacon going flash, flash, flash.
Yeah.
Right. That's all you'd see happening. Every time the sun came around, it was in perfect 90 degrees or 120, whatever it is, to the diamond. It would just flash like a twinkling star.
Isn't that like we see the stars? The stars especially.
Precisely, yeah. So that's a profound thought, right? I was thinking, well, if we're like that, if we consider ourselves as we're a self-contained universe inside of a crystal construct star type thing, then the stars that we see on the outside shining in could also be the same thing. So every star crystal could be a self-contained universe in itself. The string, that's where they string together.
Wow.
Right.
Oh, that's a lot of universes. A lot of realms,
well,
actually.
It could be like infinite realms. So that's where you get into that, the multiverse string theory universe type of thing. So, this could be along that proof of concept, right? In a 3D model sense, scaling up from the 2D map, right? Just keep scaling it up.
Yeah, so far I figured that it has to be our own universe. Because it's within our own toroidal field in that sense. The biggest one, what is possible in that sense. The bigger body of the 49 heaven and earth circles. That's only one, and that you have 7 times as a bigger fruit of life, but that you have also 7 times, and that creates the universal level. And outside of that, there is then the what they call the multiverse, with this particular diamond structure of collection of universes. What is kind of mother universe, creating child universes. What is expanding outside of that as a bubble, and even ending up as a new mother universe between all the other multiverses, etc. And building up a universe after universe, growing and growing and growing. But so far I haven't figured the actual circumference, equated circumference is growing. That's something
exactly
that should actually be actually measurable in a way.
Yeah, it would be relative to the amount of energy coming in.
So far, I figured we need to look better to the elevation data itself as well, because I see things happening there that I'm really wondering. Okay, but why are these here, for example? Completely replacements of what I figured. How does that work? Something happened here.
And something that's interesting too is
there's a spatial growth. There can be a growth in the land, but yeah, that doesn't mean that we're growing in space as well.
Well, exactly, right. I think the whole expanding, the Big Bang expanding space thing is completely up to lunch. There's no evidence or proof for it. They've debunked the whole Doppler redshift effect, and all that stuff has been tossed out with the bathwater, right? It's no longer valid. And especially if you think about it in this construct, is because in order to have vibration and light and propagation of magnetic fields and electric universes, you need a perimeter. It has to be contained within something, and it has to be a conductor. It has to be a conductor, right? A superconductor of some kind, obviously, and carbon. A black diamond carbon type of conductor would be the most logical physical thing I could think of that would do that. An anisotropic realm. One thing I did notice in this model too, I found kind of interesting, to make the moon operate properly.
Ooh, honest realm.
The moon, I had to make the material of the moon, and this is interesting. The material of the moon in the construct here is, it is transparent. A transparent body with a volume scatter of a density of 333 parts. It has a density of 333. So it's it'd be classed as a semi-transparent body that allows light to gather within it and reflect back out of it. But it's also solid, like a powdery type of thing.
Yeah.
And that's the only way you can get those nice reflections and shadows, and it works the right crescent line on it. Otherwise it looks like that's the physical. So I had to program it as particles, so you can see that it's volume scatter, particle physics with a density, and it's a transparent medium. If I change it to a diffuse, which is a solid, right? If I change it to a solid medium, then it doesn't work.
Yeah.
You can see where all the particles, and it just so all the folks that like the transparent holographic moon will just love that, right? Because they're gonna love that. So it has to be transparent, volume scatter 333. And you'll see too that in the left hand top corner, I'm going to remove some of the torus fields because they become annoying, all those lines, after a while. Don't need that
At some
one.
point there.
I got most of them turned off. Yeah. But you see in the top left hand corner there, that little purple dot.
Yeah.
If I zoom in on it. There.
Yeah.
So that's the moon, yeah. As seen from space. Outside of it, right? Because the light, like I said, the light's going, so we see the light from down here looking up, but from space you'd see nothing, right? Just a purple backscattered
It's
image.
so like with those glass balls with that electrical pulse stuff within it. But
It's a
then
plasma ball, yeah.
yeah, plasma balls. But then it's such a way that it is fully lit.
That's right. Yeah. It's black light. It's like a black light type of plasma system. And that makes sense, because I know in all the high altitude balloon flights and everything we've done, all the recording of, when you get up high enough, then the stars disappear, the sun becomes like a pinpoint ray of light, which makes sense because there's no more atmosphere to refract in. So then that becomes like the morning star effect that I showed you earlier there. It's just a infinite point of light. Then the moon, of course, you can see the moon in high altitude balloon flights, but you can't. The sun, you're always chasing it. You'll never find it because it's always relative to you when you look at it. Right? There's no way to tell where it is or how far away it is. All you can tell is its approximate angle of refraction.
Exactly.
Yeah, because if I turn that into there's the moon, right? And then you try to render it. and it goes black purple, right? Because I'm looking outside of the realm.
Yeah.
I can zoom back in. That was a problem. Like I wanted to.
So what you're saying, the sun is outside and the moon is inside of the firmament thing. Okay, cool.
Yeah, the sun is outside of the diamond and the moon is inside, closer to us. Yeah. I don't have Venus and Mercury on here, but I can turn Venus and Mercury on, and Venus is. I was going to do that for you here in a second. So
In this way, we can build up the whole solar system.
yeah, if I select Venus, yeah, Venus is the sun is approximately out here in this Taurus. If I turn its, where's the right Taurus? I gotta label these better so I can find them quicker when we're online here. Right. So this would be the sun following this, and you can see why the sun, if you look at it from the side, you can now see why it would make an analemma, right? It's going to be doing this type of around and around and around, figure 8 on an angle, right? Relative to us. So we would see it tilted. And then, so the sun is way out here, Venus is in this toroid, that magnetic field, and we're way, way in the middle with the moon, and this is us.
Yeah.
At the center, in the nucleus. You can consider it a nucleus.
Yeah.
But what I was going to do was...
Is the world scale itself then right? Compared to the whole, because you're actually working from a perspective point of your personal perspective with the camera from the middle.
The camera is from the middle, yeah, and I set that to, I can set it to whatever I want, but in that case, it was a 250 millimeter zoom lens. But I can set it, when I set it down to 2.7 millimeter with a 17 mil, so it'd be a 2.7 for our eyes. I can set it to the human eye too, and then look around, and I've been doing that too. And I was going to show you this here. Some folks might like this too, if I make this a bit smaller.
Mm-hmm.
So relative to us, the sun is still out here. And if you look north-south from our axis, because everything is inside really, you have to remember it's all inside really. Everything we see, the sun's going around and the moon's going on this way more or less to us. But when we look north-south and track Venus over 3,000 days, so each little dot is a picture of Venus, and it actually creates this pattern in the sky over 4 years.
Yeah, is that like what all the stars are doing then? Because I always felt, from my perspective, even though they kind of go around, it would be something like that, as they're sort of clicking into their positions. I never saw them going round and round like the pictures in the camera. They go around like that I can understand. Yeah,
the planets do this. Yeah, Venus, Mercury, like the 7 inner planets, all make this type of flower pattern. And the outer ones make the perfect circles, the star trails. And that's because you're looking through like the barrel of a gun or a sight, right? And it's just spinning around in that type of circle. And they follow these paths, right? On the north to south.
Yeah.
But if I zoom out and look at from the side and just turn that, I'll turn the Venus path off. Then we're on this plane axis, right? East-west.
This is also what you take with you. This particular field is what you take with you when you walk east-west, and this is why you see the north and the south center of the circle always in parallel direction.
Yeah, if you're traveling east-west and you look up, right? And if you went too
You
far
always
south, then you would lose north-south if you go.
direction. Well, you will always see in the same parallel direction, no matter on what longitude you are, because this is the particular field what you are taking with you within the square construct, or through the square construct, what just loops in itself.
That's right. Yeah, because you'd be on this axis, looking sideways, right? North-south is actually going this way. So Polaris would be up here, right? And the southern would be down here. Yeah.
This is probably the bubble of your of the whole sky of the complete square over that particular field of the toroid, what you see as your bubble around you, and then only part of that particular bubble upwards.
And that would be why the readings, like when the Dave is getting on the equatorial line, is within that, the distance from, so the width of this inner toroid section here, from here to there, measures from the Tropic of Cancer to the Tropic of Capricorn.
Yeah.
East, right, north, south. So when the moon just kind of bounces back and forth in here, then that's why you would see that type of flip-flop. So if you, as soon as you cross north-south, then you'll see it kind of morph and flip upside down to your perspective.
Yeah,
that's how I see it.
yeah, and then you have to imagine then that that particular donut is actually going through the spatial loop. But for your perspective, it's actually bent around as a circle. This is kind of you see the fourth dimension in your three dimension as if the world is a ball indeed.
That's right. Yeah, you would see. Yeah, you see it. Yeah, we live on a flat plane and we see it as a ball. We measure it. We measure it in square distances. But yet then we map the stars relative to the ball, to the ground, right, which is flat. And yeah, so it's tricky. But in actual fact, it's a toroid. That's why it's so hard to figure. That's strange, right?
Yeah.
It's a fourth dimensional toroid. Yeah. Yeah. That's what the data says anyway.
Yeah, I can't deny the data, let alone lie it.
So I can see, you know, with the geometries being that complex. I mean, it's simple when you think about it, but it's the geometry involved is complex. I can see why Copernicus and whoever else, you know, Cassini and whoever, why it would be a whole lot easier to say, well, let's just make and then map everything to that, because it'd be a lot easier from a technical perspective.
You don't think that they were in on the conspiracy then?
I think it's just.
So far, I figured that they chose the latitude longitude 0.0 not for nothing, because it actually lines up the way of the sun. The golden ratio between the tropic the tropic and the equator as the crossing point of the analemma of the sun, and the actual elevation data itself in how the pillars are located. If you understand the move, you have 0.0, but you have also minus 19 degree west and 1.5 degree north to actually line up with the particular 0 point of the heart chakra of the tree of life, where out of the triple circles are actually generating the pillars of the earth. And they call it the 4 pillars within the first circle, within the square. but the forest pillars are actually tied in the toroidal field of the next realm. And what we have at the southern and the northern edge is actually etching our own toroidal field.
Yeah, you could stack them up. Yeah, that's it. That's it. If you consider each crystal realm as its own self-contained universe, then they just would be like atoms in a string, right? Or molecules in a chemical chain.
Yeah.
Each one just connected to the next. So there would be some sort of an electrical connection between them, which you could consider, I suppose, like a wormhole type thing or something.
You need
Can I ask you something?
points to go through, you mean?
Yeah, I don't know who's going through that, but you know, flying around in space in a vacuum in spacesuits and stuff isn't going to cut it. You're going to have to go dead through the center of the northern field to get to the,
Chris,
to
are
the next
the stars? Are the stars, like, I've heard people wonder whether the southern hemisphere is a reflection or the stars are reflecting themselves. Is that what's happening? Is it all like reflection? Then it looks like there's millions of stars. There is maybe loads of stars, but not as many because they're all reflected again. Because of what you just said with that.
Yeah, some are reflections. Yeah. Oops, let me escape out of that. Yeah, some are reflections because I've noticed that too. Right, when you take a picture of the stars on the water, then only some of them appear in the water. So some of them are, some I would think would be, you know, real crystal emitters, similar to here. I mean, it's a self-contained type of thing. Then there could be stuff inside them too, like other realms inside the stars, because they're focal points of light. But then others are just reflecting off of our lens. We look up, and the lens we look through acts like a mirror within a mirror within a mirror.
Is that because of all the ones that are different colours? Because you do see different coloured stars, don't you? Some are really glistening and so multicoloured, they're amazing. Some are darker, some are lighter.
Yeah, I think the ones you can actually catch that have that crazy magnetic field, you can actually see the center of a solid object and a magnetic flower coming out of them. I can't remember which one it is, but there's one that's really cool. And when you catch it on like a P900 camera or whatever. So, you know, those are focal points of the magnetic field, which wouldn't be any much different than what we are right here. So you'll see them as a gaseous type of solid in a magnetic field emitting light. But the light's going into it, right? So we're only seeing the light as it actually enters into whatever that is on the outside. So what we're looking at from the outside in would be like, it would probably be similar to if you were looking here and you saw the aurora, right, from the outside in.
Can I say something else,
But a lot
Chris?
of them are just reflections. Yeah.
Remember I said in January I watched twice with the 2 moon equinoxes a month. I actually saw the moon dragging the stars. They came with the moon. The moon came along at its angle, and then say at a certain time it started going a different direction. It was still sort of going west, but it was going north west. And then when it did this bit for an hour and then stopped, all the stars came with it. I was like, whoa. And then when it sort of like dropped the stars off, and then it went west. The moon just went west.
So it kind of bounced around inside a refracting mirror type of thing. Yeah.
It's almost like it did a heartbeat, doing, because it came at an angle, went north, and then went off west. But that's how the stars get moved around. It's the moon that moves the stars around into its seasons.
You mean physically drag them? Yeah.
I watched it, yeah. I couldn't tell you what was happening to the rest of the sky, because when I was looking out my window, I was almost going like, oh my goodness, I've never seen that before. But I saw it twice in January because of the timings, because they were at night time, there was no clouds. And all the stars came in all the stars and the moon started coming north. I even saw
I could see that.
Orion was moving.
I can see it like in
the moon.
yeah, that in the toroid, yeah. That could be like a secondary refraction is kind of what I'm thinking. Because you'd have a primary refraction in the dome that we'd look through, and then this magnetic field in the donut could cause secondary refraction, which is why I think when Dave goes to measure it, sometimes the moon will seem to arc one direction, then arc backwards on itself from where he's trying to film it over a night. Like it'll go east-west and then start to come back. Even like on his moon calc when he calculates the angles. He'd be the best man to ask about all that. But as far as tracking the moon, I did notice that in the model, because of the refraction, you can see up here in the right-hand side where the stars will actually start to automatically generate its own little star field. I mean, it's obviously not Orion or nothing, but it's trying to generate the particles the way they reflect.
I'll tell you something, Chris. I've been working with Ceres for so long now, and Ceres has been talking about a lot of this stuff, and now I can see Ceres work in your work. How does that feel, Ceres?
Satisfying. Finally, somebody else is actually on the right track. Yeah.
Yeah, it's cool, yeah. I don't have this quite working right, but what I did do is I took the magnetic field from, and let me go to one screen here. Maybe it'd be easier for you to see.
If everybody can see, Patricia keeps leaving and coming because it keeps throwing her off. Poor Patricia.
Yeah.
I'll make it a little bit bigger. Just focusing on this image here.
Hello, Patricia.
So what this is, there's a layer. I put a layer just above the camera, and it's the background radiation map, supposedly of the universe, and I made it transparent. And when I turned it on, you can actually see the patterns in the sky. It simulates. Right. Because that's part of my interest too, is because Dr. Pierre Robitaille, does magnetic resonance, a PhD physicist, and he's come out publicly and said that what they're actually measuring with all the radio telescopes and stuff is just, as far as the W map, which is the cosmic background radiation map. He's saying it's just a reflection. So, and I wanted to see if I overlaid it, what it would look like, right, against the moon backdrop. Because when you take an image and you zoom way in with the camera on the moon, and you see that waviness going all the time. It's like it's shimmering in water.
Oh yeah. The waves between the wave layer.
Right.
You mean?
Yeah, the wave layer. Yeah, so it's like a magnetic field.
Really.
Reflecting back at us. So when we look up into it with telescopes and radio telescopes, what they think is the universe, it's really close, and it's just a magnetic field, and we're seeing it ripple like a mirage ripples. It's behaving like a mirage on hot pavement, but we're looking up through it, and it's just a magnetic field
through the waters.
through the waters. Yeah.
Hello, Billy.
Right.
Hello, how are you?
Hello.
Can you
Have
hear
you
me?
seen any? We can.
Beautiful.
Billy's in the house. Billy, have you seen anything about what's been happening on here at all?
I just got home. I've been working out of town. Will be for the next couple nights, and then I'm smooth sailing from here on out.
Hey.
No, I'm catching it right now. I literally just got home, so.
Maybe you could explain a little bit more, Chris, again. Sorry, Chris, but then probably for some of us, we need to hear it again and again.
I'll turn off that map here too. How you doing, Billy?
I'm doing good, Chris, and you?
Good. So I'll give you the quick rundown here. So what's going on here is I'm just trying to do a demo of the. You see the flower of life down in the bottom right corner?
Yes,
And
I
the
do.
little object there, that little object that's lit up is the sun following that toroidal field.
Right.
And if I rotate it backwards, counterclockwise, you can see the moon image. So there's a camera on the ground looking up at the moon, a 250 millimeter camera on the flat map looking up. And you'll see the moon go through its cycles. So there's a new moon, crescent moon. So the camera's at the equator.
Nice.
So there's not a single moon phase, day or night, that this model will replicate. And all it is a solid, semi-transparent moon body, and then the sun's just rotating around in the toroidal field across the east-west.
Yeah. But is the crystal itself also rotating?
No, it's just the sun going outside, and the crystal always focuses all light from any direction to the center.
So the crystal itself is static.
Yeah.
Oh, I wonder if
It makes
if
sense.
it's the other way around as well, so that the crystal is actually the one turning.
It could be, and we wouldn't.
The thing is, which one?
It would, yeah. I don't know which one. I mean, it doesn't matter. And Dave Marsh and I were talking about that. As I was talking to Steve Torrance as well about it too.
Dave Marsh is going to come on, I think. I've just sent him the link.
That's the thing,
it's
right?
not either one or the other.
He says he's got something interesting to show.
Oh, cool.
That's what got me into this too, is because I ran into the problem of parallax. Right? If you take, I don't know. So if you're in one perspective, and you take a bunch of objects and you place them at different distances away from you, and heights we can call it an altitude, and they're at different heights and different distances apart, and then you start spinning like you're on a merry-go-round. Well, what happens is some of those objects, because one's way high and one's way low, the arc lengths that they swing will be different, even though they could be directly underneath each other. The closer one will, it'll curve a larger path. The further one, even though it might be further away, in arc width will be closer. It'll appear closer. The parallax.
Yeah.
Which is like when you're driving on the highway and you see stuff way in the distance will actually look like it's going backwards and you're going forward. So that's parallax. So to make the universal model work, they set parallax to infinity. So one or the other has to be static. I mean, either Earth is static and stationary, or the stars have to be static and stationary. That's the only way it works. And so that's part of the how they made it work in the globe model. They set all the stars to infinity. That's the only way they can make it work. Which isn't the truth, obviously. It's not actually happening that way. We're static, and it's going around us in a perfect clockwork.
Yeah.
The only thing I can't do in this model is I'd like to be able to show you, but I can't do it, is the sun, and then, but to do it, because they're two different axes, right? Axes. So I can't turn the camera on the z-axis and the moon and sun on the y at the same time. But that's what you'd have to do to replicate like a month or whatever. But you can see if I set the moon down at 4 o'clock on the clock and look up, well, there's your daytime moon being lit from the underside, type of thing.
Hey,
That, Billy?
While you're talking
Really
about
good.
that stuff, explain to Billy the light thing again. I know that it's probably the third time we've explained it, but we don't mind. Explain to him about the light, Chris.
Let's just keep it at that. Well, what I found in order to make this work, Billy, was that I had to make the light anisotropic, so that the light coming from the sun comes into the crystal and it all goes to one direction. All of it ends up going back to the sun, so it travels in one direction. It's a linear thing. Anisotropic light is the only way to make it work, if that makes sense. So light goes in one direction only, and it goes beyond where you think it is, and then comes back as a reflection. So what we think we're seeing as light is actually the shadow, sort of thing. All the shadows point back to the sun. There was I'll exit out of this one and show you what I showed earlier.
On sunspots, then that multiple stars are reflecting back their shadow onto the sun. Multiple planets, I mean.
Could be, yeah. I definitely think that one I showed you earlier was Earth being reflected on the Earth spot.
So we're still hyperdimensional, and we still have the sun and the moon traveling in a straight line, correct?
Exactly.
Yeah, east-west.
Okay.
Yeah, they are Cobra top, but they follow a straight line.
Well, that's really good, because I just saw some videos where circumnavigation around the circle-centric A&E map, and there's no east or west. There's only north or south. So I don't know how anybody travels around on a circular map. They would never know which way east or west was.
It appears to us as, like, when we observe it and measure it, it appears as a dome. Right when we look up, because there's pressure.
Exactly.
And we're mapping it to a square map, but it's an arched dome above, and we're just mapping it to a square map.
I was noticing that someone posted a video of the sun, and it had a sunspot, and the sunspot was traveling counterclockwise across the face of the sun, where NASA has the sun, revolving as a big fireball in the sky. However, this person videotaped the sun over several hours and noticed the sunspot was moving on the face of the sun in a counterclockwise direction. So the sun and the moon both roll as a wheel in the sky, not revolving in some kind of ball or spear fashion, but actually like a wheel. We notice that the moon face, changes from top to bottom as well, as it makes a revolution.
I got too many things to go right now. That's exactly it, though. It's I showed it earlier before you come on, Billy, that there was a fellow. I'll just explain it to you. He took 6 pictures of the moon over 6 hours, and the dark spot was, say, at 11 o'clock high, and then 6 hours later, it was down to about 7 o'clock on the clock.
Exactly. Mm-hmm.
So it over the 6 hours, it traveled about a quarter turn. So that tells me that the shadow that's being cast on the sun is actually coming from here, going back, because the size of the sun travels over, right?
Isn't that what
our shadow?
Santos said that fellow scientists that work with Marconi said the exact same thing.
Could be. It could be.
When he was on that time, when he was discussing the Italian gentleman, it was all in Italian, and he was talking about how they made a device that would measure any movement in the earth whatsoever, and they built a device back in the 50s that would detect any motion of the Earth whatsoever. And he said there was absolutely no motion, and that the sun received its light from the Earth in a spiral energy wave from the Earth
Yeah,
to the
back.
sky.
It's backward.
Something like that.
Yeah, I remember I don't think I've seen that video, but I know the experiment that he's referring to, which is the Michelson-Morley experiment. And what they did is they set up lasers, and then the theory was that if there was any motion of the Earth, then all light coming here would have an effect on the light that they were trying to measure. It would actually move it, right, cause a disturbance in the path of the light, and they never detected anything. So in Einstein's theory of special relativity, when he's talking about the electrodynamics of moving bodies, he actually states that in that theory. If you go and find the PDF, you can look at it. And in his notes, there's notes that says that the Earth has been assigned to a pendulum clock. So it just kind of slowly is a pendulum. It doesn't rotate, it's stationary, but it just kind of moves motion like a rocking cradle. And he acknowledges that Michelson-Morley experiment was valid, that they found absolutely no motion of the Earth relative to the light itself. And he said so he had to take it out of the equations. So that's absolutely 100% correct. Yeah, all light goes back to the source of the sun, or whatever the sun is. All light goes back to that. Yeah, strangely enough.
And it's the other way around to what we think it happens like.
Yeah, and I've noticed that in the model too, where the sun appears in the sky is actually not the sun; it's the reflection. Believe it or not. Yeah.
That makes sense.
Yeah.
Well, see, there's been some talk, about the simulation. We're actually in the four-dimensional sun or sky or anything. That's an actual representation of the sun, but in a four-dimensional universe, everyone's getting the exact same representation because the simulation's not going to give off the frequency from the Earth with the heat and the light. I mean, I could see if it was a simulation which I don't, and I think that's just the way the skies are. And I don't even think that they're holographic in the sense that they're actually literal objects that emanate from another dimension into our dimension. So it's a fourth dimensional object in our three-dimensional reality. In other words, people are talking, well, look at the sun, how it's circulating the North Pole and the Arctic right now. Look, it's clearly, well, that's funny. If you stand facing north with your back to the south and you're watching the sun circling, so they say, well, how can it be circling up north and be thousands of miles south on the Tropic of Cancer at the same time? How can that sun that's circling up in the Arctic be visible at the tip of Chile that's in the Eastern time zone, the same time zone as we are in the United States? Okay? The reason being is that the sun, moon, and the stars are hyperdimensional. They can appear in our three-dimensional reality. Everyone gets their own personal view. It's just that simple. Yeah. And when people say that it's ridiculous, go ahead,
Billy, everyone has a unique position in time and space.
Exactly. And so, well, what about the high altitude balloon footage? I'm glad they bring that up. High altitude balloon footage. Let's say we're shooting it here in New York. We have a hot spot on a cloud. The sun is visible. Well, how far can a GoPro camera see? Okay. New York is thousands of miles from the Tropic of Cancer, and it looks like the sun is north from the GoPro footage of the high altitude balloon. So how can we have a hot spot in New York State from a high altitude balloon footage of the sun, and yet the sun is circling, so they say, the Tropic of Cancer thousands of miles to the south?
Yeah.
How can the sun be in two different spots at the same time if it's a three-dimensional sun? So, like I said, I'm not gonna. People are, everyone's entitled to their opinion, and these questions need to be asked. You also need to ask about the flight patterns. I saw someone did a video again. They're mentioning flight patterns. Well, it's just this simple. Show us a flight pattern from Canada to Russia across the North Pole. There isn't any. Yeah, the flight patterns work on the A&E map as long as you're north of their circled equator, but go south of the equator on the circle map, and the flight patterns become horrendous. But they don't want to talk about that. And they want to. I was very disturbed when someone said that the square D 4D map was ridiculous, ludicrous, and a joke. Well, what about the A&E map where the day and night don't line up in the wave pattern? What about the A&E map where the spring and fall equinox don't line up? Okay, these are some things, as well as the flight patterns. They keep having the jet streams at 800 to 1,000 miles to make their flight patterns work on the A&E map. And they're really pushing that jet stream issue. I mean, and they're really pushing the fact of the midnight sun in the north. And there is video and people on record that they observed a midnight sun into Antarctica as well, but they disregard any information about that. And they disregard the fact that they want to use Gleason and Rothenbaum from hundreds of years ago, who came up with the synthetic astronomy of the Earth being a round disk with an ice barrier to the south. That's hundreds of years old information. Let's bring it up to the 21st century, where we have Google Maps showing the square grid system of our Earth, and it's all mapped out aerial. Why don't we say that all NATO and all militaries use the Universal Transverse Mercator Projection grid system to locate themselves, as well as GPS? So let's just bring it up a little bit into the 21st century. And, we have the technology now that they absolutely know the shape of the Earth. So they're pushing a false narrative.
They definitely do.
Billy.
Yes.
Sorry, hello.
Oh, Dave. Okay, great.
All right. Yeah,
Sorry,
on the back of that, I know what you're referring to, because I left a comment on one of the channels asking why the person never thought to mention my moon race experiment, and I actually got attacked by some other subscribers in the group, saying I'm trying to just get my message out to promote my video to get the views, which I never even copied and pasted the actual link to the video, because obviously I just wanted to get the message through to this person. So I asked him the simple question: does he believe that the moon would need to speed up on the AE model when it obtains southern declination? That's all I've asked. Yeah, and a couple of people replied back, and I got attacked by one. So what I've done, I just did another experiment last night to put another nail in the coffin, should I say. It's funny you should mention Robotham, because if you read synthetic astronomy, what you'll find is Robotham did an experiment where he used like a pipe, and he fixed it in a location onto Polaris, and he proved that Polaris was a fixed star and it never moved. That was back in 1865. This is 2017. Yeah. So what I've done, I set up last night my camera on the back. I located Polaris. It's not easy to get Polaris on a camera. Trust me, it's hard work because it's so dim. It's very difficult to get it into the actual focus. You have to do manual focus, and you have to just keep moving around until you find it. It took me about 20 minutes to find it. So what I did last night, I zoomed in on Polaris at times 120 zoom, the maximum zoom, and I left my camera rolling for half an hour outside. And when I brought the camera in and uploaded it to my screen, well, if Polaris is a fixed star, well, it's very funny because it's moved from one end of my screen to the other, which I knew it would anyway, because I know it's off by 1 degree. And I've got it on video, and I'm halfway through making a video. And if you want, I can show you the video in a bit if you want to see that Polaris is not a fixed star. It's 1 degree off center, and it does move. And I've got undeniable proof that it does. So I thought I'd put the video out.
I'm glad.
I wonder what the issue actually is. That there is there some kind of thing that they're at the center of the turning points of the north and south. Has there to be a star, or what is this particular issue about the star in the middle of that particular rotation?
I don't know, because it's not in the middle anyway. Like I say, even when you zoom in on Stellarium, what you'll see, it's way off center when you zoom right in, get it, because you can zoom right in on Stellarium, and you can see clearly, if you set it running at time, I don't know, times 500 or whatever, and turn the daylight off, you'll just see it whizzing around in a little circle. You know what I mean? Yeah. It's not in the center. Like I say, if it was in the center, it wouldn't move. And like I say, I've documented it last night. 29 minutes footage, and it starts at the just below the middle of my screen, and within half an hour, it's at the top of the screen.
So Polaris has a very tight orbital pattern around the northern celestial pole, and that's the tightest star. And probably Cygnus Octantis has the same in the southern celestial pole and has the tightest orbit around in the south. I was going to bring that up, Dave. I didn't see it came on because I was watching the chat screen, and I'm glad you brought that up. Not to mention the moon race videos, where actually the moon is the slowest on the Tropic of Capricorn and the fastest on the equator. And yes, they would have to change speed on the A&E map, as well as the sun. Okay, so we have 14 hours of daylight north of the equator on latitudes and similar latitudes south of the equator after the winter solstice has 14 hours of sunlight. Well, how is that possible? The sun would have to be traveling 70 times faster than normal from the Tropic of Cancer to the Tropic of Capricorn. And they don't want to discuss this. They don't want to discuss how does the Ama-Lima orbits work on the sun and the moon when it circles from one. They just want to keep showing a compass and putting a magnet in north. But you know, if you do that same experiment and you line the northern wall with magnets and you slide your compass across a square map, your compass is going to point north. It doesn't have to be on a circle-centric map, okay? And on a square map, we have a true east and west. And what people need to do is a solography, long exposure, camera exposure up in this Arctic midnight sun, and you will see that the sun's path is straight. And what they're observing is the sun setting and the sun rising. The sun setting in the west and then rising in the east. And it's not circling anything. And once again, how can we see a sun in the north when it's all the way down on the Tropic of Cancer, thousands of miles to the south? Why? It's because the sun is hyperdimensional. It can be in several spots at the same time simultaneously proving that it's not three-dimensional. It's just that simple, people. I'm sorry that you can't get your heads around it. And I've been called a lunatic. I've been called every name under the book because I'm willing to discuss these things. You know, we know that in a three-dimensional universe, an object cannot occupy two different spots at the same time. However, the sun can. Just like Siri said, everyone has their own individual perspective of their sun wherever they're at. So, you know, how can the sun be 3,400 miles up when is that? You ask him a question, well, the sun's 3,400 miles up in the sky. When is that? During the height of the Amalima? Well, how high is the sun during the lowest point in the Amalima? They don't want to discuss that. How many miles difference does it change in altitude? Okay, what causes the change in the altitude from the Tropic of Cancer to the Tropic of Cancer, Capricorn? They don't want to answer those questions. So, like I said, I mean, one thing's for sure, we don't live on a globe. And the second thing is there's a lot of problems with the A&E projection, map projection, that have to be reconciled before you're actually teaching that model as ipso facto, because it's not what they use. It's not what the governments know. Google knows, and they show you right to your face. Just that simple. This is the square grid. Look at your local state map. Pull out a map, an old-fashioned map. Everything has a square grid around it, because that's the way cartography works. That's the way astronomers view stars. If someone would study Tycho Brahe, does anybody know? To Tycho Brahe, his star calculations are still used today, and Tycho Brahe mapped out all his stars on a square grid pattern.
Google Sky builds up all the sky photography in just the same square as the ETM map of ETM photographic material. But then in mirror,
that's
because
another
we're
person that they hid. And Tycho Brahe knew that it was a geocentric universe as well. He was not a proponent of the heliocentric model of the universe. That's why so many people don't know too much about Tycho. Okay.
Yeah, I think Darren he used a lot of his research in his last video he made, didn't he? If I remember rightly, because I thought he based it on Ptolemy actually, because it was very similar to the Ptolemy system, and
yes,
but he messaged back saying no, it was Tycho. So I know it's a very similar system, right? All based on geocentrism. So, but I haven't researched him a lot, to tell you the truth, but his name has popped up quite a few times, and I think he was like the thorn in the side to the heliocentrists.
I thought that your moon race video, and I saw a lot of the comments when I watched them both, Moon Race 1 and Moon Race 2, that pretty much sealed the fact that the sun or the moon was not circling anything, and that it was on a linear straight path, and that there was very little time variation from the Tropic of Cancer to the Tropic of Capricorn and to the equator. By no means is it a 70% increase from Cancer to Capricorn, and that's what would be needed on a circular A&E map, as well as the sun would have to increase in speed and decrease in speed. And then you ask them, well, how is that done? What mechanism, what causes that? Is there geomagnetic lines in a circular path underneath the earth that make it slow down and speed up? They just want to focus on 800-mile and the 1,000-mile jet streams, and they want to keep focusing, ramming down the midnight sun in the north. Look at it circling. Well, it's not circling. Okay? There is an other explanation. And why these people refuse to visit this other explanation is beyond me. I don't know why. So after these things are brought up, and then when you ask the questions and you get mocked and you're ridiculed and you're taken for a joke and it's ridiculous.
Billy, you know why they take you as a joke? Because it's their own assumptions of what they think, what you say, in a sense that when you say square, they say Pac-Man, portal, wall.
Right.
In other words, they associate all the different words with just the word square, and you don't say them. But they assume it, and they attack you for their own assumptions. So it's actually addressing them on their own assumptions instead of defending your square.
Well, right now, I wish you guys could get a look at my sun. My sun is high in the sky still, but it's in the westernly sky. And right now, it's 6:10 in the morning in China. And you mean to tell me I'm looking at a sun that's 6,000 miles away? That's 3,400 miles up and 6,000 miles to the west, and now is rising in the east in China right now?
The sun is actually on the other side of the circle.
That's correct. That's exactly what
yeah.
it is. So,
a few people in the chat room aren't getting this, by the way.
Hmm?
I don't quite get the multi-locational sun. I can't get my head around multi-dimensional sun.
well,
it appears that way. You know, it's a refraction index too, right? It depends on the angle. It can appear in more than one place at the same time. Is probably an easier way to try to explain it to them.
yeah, that's an easier way to explain it, is that the sun can be in a different place at the same time.
Yeah, where the apparent sun would be.
Right.
If I look
I think that these things are your 3D reality of wherever you're at, because that sun will give you heat, warmth, light. It's not a simulated. That's your sun reality in your 3-dimensional. However, the sun is a 4-dimensional, because 20 miles down the road, your neighbor has the exact same representation as you do, but a cloud could be blocking his sun where you have clear skies, 20 miles apart from each other. And they're so close. So you send up a high altitude balloon and you see the sun, let's say in New York State, all right, it's visible. How you think a GoPro camera can shoot a sun's location thousands of miles to the south when it's supposed to be circling on the Tropic of Cancer?
Yeah.
Or how could the high altitude balloon footage capture a sun if you're up 25 to 30 miles up in the atmosphere, that a sun is 3,400 miles above that? So you're talking another 3,000 miles up, but yet a camera's capturing a glimpse of that sun? How is that possible? How is the GoPro camera panning upward 3,000 miles? It's not. Okay.
The apparent sun, like in the image I pulled up here, this is from the model that actually works. Now I can show you some comparisons so folks can wrap their heads around it. But the light that I had to
explain to people that are in here, the land is still flat and square. This is above.
Right, this would be above and outside of the refractive dome index. All right, so the flat plane's down here. We're on the map. And this is actually taking the camera, what would be space if we could get to space, looking back at the refractive index. So this is the shape I had to make all the refractions work. These images here. So this is what's actually happening here is the sun is a UV light, black light, So think of it like a black light in a nightclub situation. It's black light. You can't see it when you're looking directly at it, but the light comes out, and then because it's a one-way street with light, it comes backwards, and so it lights up our realm, which is casting this shadow back towards the sun and lighting up the moon on the backside. So from the ground, when we are actually in, where's the other picture here? We're inside looking up, and we see the dot of light on the surface of our refractive medium. That's where we would see it. If you're at center of the equator looking up, you'd see the sun. But if you change the angle of the sun, then it can appear different. Up here, say the North Pole, if it was up here, if you're in the north, and the angle was different, where the sun shines in, you'd see it going around in a circle. But it's just going back and forth, right? Because it's such a short arc. By the time it sets on one side, it's rising again instantly, and the other side, it's always present in the sky. But to the equator, it's gone. It's too far out of range. And the way I know that's for sure is a friend of mine on Facebook here just yesterday took these pictures. So this is the sun from Sao Paulo, Brazil by Anderson Neves. And if you watch the spot travel its arc on the sun over 6 hours is a quarter turn. Translates to essentially what would be that shadow appearing on the sun's surface. As the sun goes in a straight line, we see it as a curved arc. Be something like this, right? Where the sun appears is relative to your eyeball, or the refractive curvature of the sky that causes the curve, right? So in space, if you're actually out there, you wouldn't see anything. Like you couldn't see the Earth at all. You'd just see a black, whatever spherical lens that we're looking through, and the moon. Because when I change the angles of it on the flat plane here, this is where we are. If I move the moon into the refractive medium, you can see it'll change where it appears. But it's only a small object, right? So these are actually from the model shots, and then I went and replicated a whole bunch of from the camera perspective on the ground, looking up to replicate shots that other people have taken in photographs. And what's interesting is when the sun is down and behind us, right? You can't even see it, but it's down and behind us, say to the east, or to the west, and you're looking east in the morning. The sun will actually appear as the morning star in the sky, but it's a refraction of the sun light in reverse appearing up here. That's actually the sun, but it's just a refraction index. Focuses all of the sun's light to a star point, and we see it as the morning star directly, and then this star will drop up in the model when I rotate it.
That's very good, because that's exactly what we observe.
Yeah, so this isn't programmed in there. So I'll just make it clear to people that this is just particles, a particle index, and this image appears automatically as I rotate the sun. This light will just appear in the sky as the morning star. So it's not Photoshop. It's just rotating the stars or rotating the sun. And in your perspective view, that's what you see across the flat plane.
The map itself isn't really on scale.
Say again?
The map itself isn't really on scale, I guess.
Well, this is it warps it because this is a fisheye lens, so it's just a flat map, and it kind of warps it a little bit in this image.
Yeah, but the map itself isn't on scale, if you ask me.
It should be, well, it should be to the width of it. Yeah, 1,200 or 12,742 kilometers.
This is the circle map. I see.
Oh, in this one, yeah, I had the in this particular image, yeah, I had the other map turned on to see if it was any different. Yeah.
Oh,
It's not the circle map; it's a different one. I was trying to map the magnetic fields flows of the. This is a magnetic field map.
that one, yeah.
Yeah, the magnetic field map. Yeah.
Yeah.
Yeah. Yeah, but the model itself is a square flat plane with an arched perspective lens dome over it, and this is just refractive error, so it's 0.065 particles per meter squared, and then this is just a red refraction and a blue. So we need the red, blue, and green refractions to make the pictures come out the right color, black.
And you have then more of these bubbles tying into each other, because the when you take the next realm and you have the same north and south extra square, those are the south actually ties in the next realm north. In the next realm north, the south ties actually into the north of our own realm, but then through circle grid, the flower of life grid.
What I found to be amazing in this model is that the way the shadows goes back towards the sun. Technically speaking, when we're at nighttime, when we're looking into the shadow, you can't see the sun, but that's actually nighttime. In the flat plane to be here, and you're looking up through the camera towards the sun, you can't see it. It's actually nighttime. But you see the flat faces lit up of the moon because it's over your head, so you could actually see this white face of the moon at an angle. So this is, you have to, everything is in side reel. That's the problem, right? It's all sideways. It's all side reel perspective. And it's hard to get your head around, but that's what's happening.
That's a good point, Chris.
Yeah.
Because that's why that.
Sorry,
Say again?
carry on.
No, go ahead. That's
that?
why you could. Okay. Go ahead, Karen.
Carry on, Bill. No, after you.
No, I was going to say that's why you could see the moon visible during the day, but not the sun and the moon visible at night. For that exact same reason, maybe.
Right. Yeah. At nighttime, we're in the shadow, and you can see the moon, but during the day, you can see them both occasionally. Yeah. Exactly it. Yeah. This is basically this lens. This would be this lens looking at this face of the moon, because I didn't move anything. I just took the camera out and looked backwards from the outside. So now you got to put yourself in a different perspective looking sideways. So it's a nighttime shot looking back at the moon from the flat plane in here, and it's actually facing the sun. Believe it or not, it's in side reel and it's reverse. So we're seeing this dark field. The sun that is actually gone from our perspective. So we're looking into this dark zone, and we see this side of the moon from an angle backwards. And now I know why too. I know why sometimes we see the occasional what looks like a star in the moon. It was because it would actually tend to do that occasionally if you got the right angles, because the model does it, right? So it's.
Chris, will you tell Dave as well what the night is? Why we get the night?
Yeah, the night's actually this shadow when we're looking at the sun. We're in our own shadow. Yeah.
Did you hear that, Dave?
Yeah. Sounds good.
Yeah. I'll stop sharing, and maybe David, you didn't see the actual model from the, because I think you came on late, right?
Yeah, I basically walked through the door at 10:30, so I literally I haven't had nothing on till I got in the house.
Here, I'll try and show you here if I can. I bring that back up.
while you're doing that, I've just had a quick flick through Zetetic Astronomy to look at what's been written about the pole stars. Actually, in Zetetic Astronomy, they dismiss the southern pole star, but in the follow-up book, Zetetic Astronomy by Lady Blunt, she actually corrects Rowbotham's mistake, because they had undeniable facts that there is a southern star rotation, because obviously in the early 1900s they had photography, and they also had like a postal service. So basically photographs had been posted of the star rotations to the Earth magazine, what we called back then. So Lady Blunt actually corrects Rowbotham, who dismisses the Southern Star. I think it's called. Does it call what's it called? Octana. I can't remember the name of it. Whatever the Southern
It's
Star.
called Cygnus Octantis,
Cygnus Octantis.
and it's very
Yeah.
yes, it's very good that you're bringing that up, Dave, because when you mention that, they immediately change the subject, like you're making this up. See,
Yeah.
people already knew, so we have to come to an agreement. Is there a southern? Now they admit that there is a southern star rotation, but there's no southern celestial pole. Okay, all right.
That matters.
I know. I can't.
Well, when they see my video, there's no northern pole star either, because it's way off center. I can prove that with the actual shot, because it should be fixed, shouldn't it? They say it's the only fixed star in the sky, but with modern technology, when you zoom in on it, you can clearly see it's moving. And I'm not the only one to film this either.
Oh, I know, Dave. Thank you for bringing that up. That makes a good point. So
yes, but just on the back of that, like I say, I was just reading a little section on the stars in Zetetic Astronomy, and it clearly says that there is a fixed North Star, but then he obviously dismissed as Cygnus Octantis. So, like I say, on the follow-up book, the Zetetic Astronomy in 1904, Lady Blunt clearly corrects Rowbotham's mistake and basically apologizes and says, yes, we put his hands up, we was wrong. There is a southern star rotation now, but it's still flat. So,
right, that's good, and we can have it like that and come to an agreement. This is why people don't take a lot of these flat Earth researchers seriously, is because they deny all these things. At first, they denied all the southern plane routes, and now they come up to, yes, after people have had videos and documentation, airline tickets, have to show them, yes, these flight routes exist, and then they go, well, it's the jet stream. You can do 800 to 1,000 miles. They just can't accept the simple fact that it might not be what you think. So
yes.
I know.
Don't the new 777s? Don't they got Mach 1 apparently?
And if you notice our group, we're not calling anybody any names. We're not saying idiot, stupid, retard, stuff like that. Because when you ask some of these people the thing, they immediately come back. You're an idiot. You're a liar. You're stupid. You're retarded. And wow. And frankly, I shared, privately with some people that I'm just not going to visit any of these channels or support them anymore. I don't want to call anybody names. Everyone's entitled to their own opinion and their own feelings and the way they think. But it's the name calling and stuff is getting old. We need to unite and come together. And if you want us to watch your research and stuff that you're coming up with and give a honest critique of what you're seeing and stuff, a lot of it's spot on. a lot of these people do excellent research within the flat Earth, but on some of it, it's far-fetched, it's fudged, and it's pushed as fact. What we're presenting is an alternative to what we're seeing, and things are lining up. And like I said, a lot of people want to deny the supernatural. I think that's why a lot of people are having a hard time with it.
Billy, we're researching online.
Exactly. We're doing it wide open out where everyone can see it. And we can be critiqued. But to mock and ridicule us for looking at alternative solutions and trying to find out where we live, you know, it's our time, it's our channel. And like I said, it's if that's what we want to do, then we don't mock anybody else, really.
So
Well, I think what
Maybe
we're trying to do is just trying to explain it to people, and other people are just reacting like they're in fear or something.
so
I
maybe
don't know what it
David,
is.
can you see my screen there, Dave?
Yes, I can.
Yeah, I'll just want to run you through this shot, and then you can kind of have it as a takeaway and see if it lines up with what you're seeing with your photographic research and everything. So this is what just so you can see how I got the model set up.
Right.
Is that so down here is the square map that I have. You can't see that, but it's actually the one with the moon readings from the group, right? And it's a square, and then it's also just laid onto the surface of this right in here, which is like what you can consider the bottom side. And this is our refracting atmosphere. And then I have the camera set up at a 250 millimeter zoom Nikon. To pick the camera by, you know, I can actually pick a camera by brand name in this thing. So then I have that set up, and then the moon is in focus right there. So that's the length of the focal length. So then I'm going to zoom out just so you can see the field. So now we're on so this would be, we're looking east-west with the camera, north-south zenith. So this would be where Polaris would be 1 degree off center up here, and Arcturus down around the bottom. When you're looking north-south. And this is the Taurus that the moon actually travels in its own field, its own magnetic field. And this up here in the right-hand corner is the actual shot that we're seeing through the camera lens, right? So we're looking west in the morning. It'd be a daytime shot. You follow me so far?
Yep, you're going to say the moon is always on that side when it sets in the west anyway. I've caught him many times on that side. Right.
So that's the shot. That's the angles. Now, now down here in the right-hand corner is the magnetic field of the sun, and I've set it outside, and I'm just going to rotate that counterclockwise. Oops, hang on. I'm going to go to make sure my cursor's centered before I do that. I have a habit of doing that. So then rotate it. So I'm going to rotate the sun on the y-axis. And you'll watch the moon go through all of its phases. So this would be like for a month as I just rotate the sun around once. And nighttime gibbous, right? Then when the moon or when the sun is underneath, there's the new moon. You get 2 or 3 days of no moon, and then full moon. Then it starts going back through the gibbous phase again until we get to the morning, and then the crescent phases. And it just keeps going like a 24-hour clock, right? And then you can see if I spin that around, well, the sun's on this. We're on this flat plane, north-south, east-west, and that's where I ended up with the toroids. And something you might find interesting as a bonus points. I like bonus points, eh? If I turn on the Venus, then render it. So we're still on the same plane here, and I zoom into that. Of course, I'm looking from the other end, but that's the toroid of Venus. If you look north-south, then we create, obviously you've seen that before, right? The flower is looking north-south. And it has its own path.
So basically, the stars are doing a merry-go-round ride up there.
Yeah.
All of them are doing it in that pattern.
Yeah, Steve Torrance did a very similar one, which
exactly
was a very similar pattern to that, actually. It's I think he did one with Venus, and he's done one with Jupiter and Saturn as well.
Yeah, the inner 7 planets, they follow that toroidal pattern, yeah. And then the stars do the circles because they're outside, they're further out. They just follow circle, locked into our magnetic field. But the inner planets, or the inner 7 and the moon, are locked into our magnetic field relative to us.
Do you know when you say magnetic field, would you be referring to ether as well, or?
Yeah, if I can show you that, I'll try to turn it on here. The Venus path, turn that off. So what I ended up having to do, if I get it to illuminate properly here, this is a bit tricky, but it does work. Okay, if I rotate the model just right, because light goes in one direction, it's anisotropic. So what you end up with is a diamond crystal, which is this to be the sun, where the sun focuses all this light through this diamond crystal, and everything appears to us inside. So it's, I'm not sure what it would be made of, but obviously that's what's going on, because the light only travels in one direction. So, you know, it could be a carbon type of carbon crystal that focuses all light inside.
Oh,
Yeah, I thought it was an hexagon at first, because that would have been a natural shape for it to form, wouldn't it? You know what I mean?
Yeah,
Yep.
but also a crystal in the sense of a static frequency.
Yeah,
Exactly.
it could be.
Cymatics, kind of.
Yeah.
Yeah.
Yeah. So all the light is always 120 degrees away from itself, and it all points in one direction to the center, and it's always vectored at 120 degrees. So I have to kind of lay this on its side on a front view, angle it, and then rotate it at 120 degrees, and you'll see that that's the only point when the sun actually, you can see it. So then if I look at, and I go over here and rotate the sun, you'll see that it just flashes on and off. There's only one point in the whole circle when the light is at full view. Right? Yeah. It's like a half moon or whatever. And in this case, I think I got Venus cast on the shadow. If you put Venus in the right spot, you can cause the lunar eclipse is actually Venus's shadow.
It's funny you should say that, because in I can't remember which book I read. It may have been Alex Gleason's book, because he did a lot on the eclipses, and he actually theorized that the eclipse was caused by Polaris, which was quite interesting. Right? Yeah, which I can't remember what section it were, but I have come across it in a book. I'm sure it was Alex Gleason's book, because there's a massive section on eclipses, and he does mention Polaris.
What was it again? The eclipse of the sun is the shadow of the Earth, or
That's it. Yeah. Yeah. The eclipse. I think the eclipse of the sun is actually the Earth's shadow. Yeah. Yeah. Or we're in the shadow, and just the way it lines up. Right? I don't think it's the moon causing that at all. Because have you ever been able to catch the moon during an eclipse, Dave? Like you actually see the moon before and after an eclipse? Or just the sun goes dark and that's it, right? I've never seen anyone capture the moon just prior or the moon crest just after.
No, because like you say, you think you'd be able to see it as it's actually doing it, but you only actually see it as it enters the light, don't you?
Yeah, so I think all we're seeing when you see the solar eclipse, all you're seeing is the Earth's shadow cutting out the light of the sun.
Yeah, a bit
relative
like
to us,
a bit like you see an insect when it steps on water and you see that water tension. Maybe it's something similar to that, like in the atmosphere.
Yeah, the same effect. That's what I'm thinking it is, because that's what happens in this model.
There is a name for it, but I can't remember. I think it begins with S.
Yeah. Yeah.
Yeah, that's
where I'm at with it.
Just remember, everybody, that it's always the opposite of what you think.
Exactly. Interestingly, I've been me and Darren Nesbitt were talking, and Darren asked me if I would build up some more data on the moon. If you remember the other night, I did go through a lot of the data with you. Well, I'm up to about June now, and it's the same pattern all the time. Now, according to the heliocentric model, like I mentioned before, when the moon is traveling at its fastest, it's when it's approaching perigee. Yeah, that's obviously when it's its closest approach. Once it's past that point, then it will start slowing down in its orbit until it reaches apogee, and then it will start speeding up again. Now, we all know that when the moon's further away, it's lower on the horizon. Yeah, so in theory, when the moon is getting northern declination, it's getting higher on the horizon when it's coming from the thingy. This is where we should see the moon speed up. In reality, think about it. When it leaves the equator to the Tropic of Capricorn, that's where it's going to have its closest approach, because obviously it's closer and it's higher. But it's doing the exact opposite. It's like I said, it's speeding up when it leaves the Tropic of Cancer and goes to the equator, and it slows down. It completely slows down to relatively the same speed it is on Cancer. It is just a fraction faster, like 2 seconds, 2 seconds over a day. So it's not a lot. It does vary from day to day, but the pattern up to now is exactly the same. There's no change in the pattern. You've got the same speed up, slow down, relative speed, speed up, slow down, relative speed, which is completely opposite to what it would be doing on the globe model, because it would be relative speed, speed up, slow down, relative speed, if you know what I mean. So it's not doing. Once I've built all this data up, obviously this data is only taken from London. What I'm going to be doing, I'm going to be taking the data from Ecuador and somewhere far south. I thought somewhere maybe in Argentina or Chile, because that's the farthest city north is I think it's in Argentina. So I will be taking the data from there to have a variation of locations. But it's all right building it from one location, because it's like I say, I know people will say, wait, it could be parallax. You know what I mean? When an object's further away, it would appear to go in slower. So that's where I'm at with that. If you want, I could share the screen and show you what I caught last night, and I'll compare it to, say, another star, and you can see the difference in the actual speeds when they're at full zoom.
Yes, please, Dave.
Right, see if I can remember how to do this. So I had that. So this is the original. Can you see my screen?
We
Yep.
can.
Okay, so this is the original footage. You'll see what I'll do. You can see how faint it is, and then what I do, I manual focus it. It does actually drift out of focus a bit, but I think that's as it's going off the screen. So basically, I found Polaris and I stuck the camera on it. And as you can see, most stars now would be drifting across the screen, either up slightly, down slightly, or to the right, obviously. But as you can see with Polaris, it's pretty stationary, isn't it?
Yeah.
But if you flick it there, boom,
Out of
Polaris
focus.
does not stay still. Polaris is moving around. This is straight from the camera, straight onto the hard drive.
But this focus is
Yeah.
changing as well.
Yeah, the focus goes slightly out a little bit as it's going out. As you can see, there's 11 minutes, 15 minutes, 18, 21, 23, 25,
Sure.
28.
It's a half a degree off, and adding up it's of a circle of 1 degree.
Oh, I don't know what happened there.
Oh, no, you touched something, Dave.
Yeah, a notification popped up on my screen and I clicked it off and it went weird. So what I've actually done to try and speed the process up. Set that off screen set.
This is what series, that's what we live in, is infinity of it traveling down the corridor of pictures like that.
Yeah.
Yeah, what I've
Welcome to the
done,
Matrix.
the software will only let me speed it up by a certain amount. So what I've done, I've had to re-record it again at I think it was times 10. So, and then what I've done it again, I've times it to 2. So I've got it at 20 times speed on the actual video itself. It's going to be at times 20 there, about a minute and a half. And then you'll be able to see clearly that Polaris isn't a fixed star. It's not in the center. Stellarium shows it that it's not in the center as well. It's like I say, I don't know whether it's half a degree or 1 degree. I'm led to believe it's somewhere closer to 1 degree off. I don't know if anybody else can shed any more light on that, but it's definitely not in the center. That is for certain. Otherwise, it wouldn't go from there to there.
Mhm.
Like I say, it's just gone out of
Is it going
focus.
up and down? Is it going like tick-tock, tick, or is it actually going round?
No, it would do a little circle in reality, but obviously I only recorded it for 30 minutes. You'd have to
Yeah, it
record
looks
it.
like
If you speed it up, you see that
it looks an awful lot like a
Yeah, it's because it's lost its focus. You see, it's drifted out of focus slightly. It's such a faint star that if you try and shoot it with autofocus, a lot of the time, what it does, it starts refocusing and all sorts, and you end up getting nothing. If you look at it at the very beginning, let me just close that and open this one again, just to show you.
it looks an awful lot like a doesn't it?
Sorry,
Doesn't it look
Chris.
an awful lot like a glowing magnetic crystal, Dave?
Yeah, like I say, it's interesting. It's got like there. Obviously, it's slightly out of focus, as you can see, and that's how faint it were when I picked it up on the camera. You know what I mean? It was. I use a manual focus, so I can get it to its proper focus point, focal point.
You can see the magnetic fields, yeah, for sure.
Yeah, there's definitely
Looks
something.
like a magnetic crystal to me.
I've got the compensation, the exposure compensation turned right up at this as well, because I couldn't pick it up without it. It was impossible. like I say, it's not the brightest star in the sky to get, but it's. So as you can see, there's undeniable truth. I know people say, well, that's not Polaris. I'll say, you try and get a star to stay on your screen for 30 minutes. Because what I'll do, I'll just give you a quick demonstration now of when you stick other stars. Let me just try and find where I put them. Yeah. For example, take Jupiter at full zoom.
You see even the moves.
You can see how fast it moves across the screen.
Yeah.
Wow.
Yeah. It's out of frame within half a minute.
Jupiter and his moons, yeah.
Yeah. So, you know what I mean? If anybody just try to deny that it is Polaris, obviously I'll just show. What I might do, I might just add a little star in the corner of the actual video I'm presenting to say, look, this is our normal star would move across the screen.
Yeah,
Also, I've got
and then zoom
Sirius.
out, mix together.
Yeah, you can see in that Jupiter shot there, Dave, too, the polarization of the light too, like same as in the what I had to do to make it work.
Yeah.
Nice job, by the way, Dave.
Yeah.
Yeah, there's a lot of.
Which one is this? What star is that?
This is Sirius. But it's shot through a lot of the atmospheric conditions were, you know what I mean? The air was quite damp, if you know what I mean, or moist, or there's a lot of moisture in the air. And what it does, it actually picks up that as well.
That star's doing some amazing shapes there that's just going off the screen.
Yeah, that's. I've also got Venus somewhere. I don't know if you've seen this one, Chris. This is Venus in manual focus. If you catch it in the daytime, you can actually see the phase.
Yeah. Yeah, Venus is the only one with a phase other than the moon.
Yeah,
right?
it's the only one I've seen with a phase.
Why not Mercury?
As you can see, the light's going down. It's following the actual light. You know what I mean? It always follows the actual light.
Did we see Mercury to do the same then?
I've never caught Mercury. In fact, I don't think I've ever seen Mercury.
Yeah, kind of only in the way of the light in front of the
That's a
sun.
great shot. Yeah.
Wow. Yeah.
Yeah, so as you can see, all the stars, this one's slightly out of focus, but you can see they all drift across the screen at a fairly fast rate. Same again here, there's a lot of atmosphere interference kind of thing. It looks like it's in water, but it's not, it's just the atmospheric conditions.
You can definitely see the magnetic torus in that one for sure.
Yeah, it's
Plasma fields, yeah.
Chris, could you just quickly explain why the stars are spinning in two different directions with the northern and the southern hemisphere? Because it's being talked about in the chat room. And I wondered if Series could put a picture up of actually the model, you know, like the whole thing series. Because you've got it in the hyperdimension thing there. Picture of his model up.
yeah, I'll come out of there.
Sorry, it's not you, Dave. Series of, it's just the chat room are asking quite a few questions. No, I was liking your stuff. They just put their pictures up. I could have whizzed between all of you.
What I tried to do, I tried to explain it in my Moonrace video. You know what I mean? That there is two vortices, and as the luminaries pass from one to the next, then obviously they're just like a magnetic field. One turns one direction and one turns the other direction, and it's simple as it goes from north to south or south to north, it will simply pick up on the opposing field. Basically, that's how I've come to the conclusion. I don't know if anybody would agree
Yep.
with me on that, but
No, I agree
Yeah.
100%. Yeah, it's each is locked into their own phase field. Yeah, and it's a frequency, so it's like a standing wave. So you have a north pole on north and south poles on them, and they spin within that. They spin within it. Right.
yeah, I was just going to show them that section in my video, but I can't remember where I put it now. It was in my documents.
I just asked series. Would you put a picture of the model up series?
Well, yeah, the basic dynamics.
No, I mean the picture that you have, like the whole thing with the Antarctica and the water.
Oh, a single picture, you mean?
Yeah, just for a few minutes. You can go back to that. Oh, and Dave's showing something now as well.
Yeah, so this is how I try to explain it.
1 second, Dave.
Like I say, I haven't done a lot of research on magnetic fields, but what I did, this is the conclusion I come to. So basically, I based the research on the ether existing, and I basically said it's some type of for a substance for the propagation of light. In other words, it's carrying the light. And it's in a constant it's in a state of constant flux of vortex motion, so it's constantly in motion, and it carries all the heavenly bodies, luminaries, according to their altitude and varying densities, and it's made up of 2 vortices. Now we know we've got the northern star, which is obviously not in the center, but that's pretty close to the actual center of the northern vortex. And I'll just pause it there. And this is 2 vortices. You've got a rotation one direction.
Sorry, Dave, you're going to have to present it again. I'm really sorry, it's gone black.
Has it?
Yeah.
Does that sometimes. It got moved around a bit and then it just suddenly goes black. So you have to.
What do I have to do? Do I have to actually share the screen again? Or?
You're doing a fine job, though, Dave.
So if I go back into it now, can you see my screen now?
Yeah.
Yeah.
Yes.
Yeah, right. Can you see the screen now, yeah?
Everything's fine now.
Yes.
Yeah.
A little bit slow.
So, like I say, in the north, the stars rotate anti-clockwise or counter-clockwise, and in the south, they rotate clockwise. Now, I know some of the big flat earthers will deny a southern star rotation. What they say is it's down to perspective, or it's due to this atmospheric lensing. Now, atmospheric conditions change. If you put your camera facing perfect north, you'll get the same star rotation night after night after night. Now, if the atmospheric conditions changed, I'm sure that you'd get a different set of star rotations in the south, especially. Because that's what they're saying. They say it's due to atmospheric conditions. It's not due to atmospheric conditions. You can see clearly that they're exactly the same.
Yeah, they're completely tied into the sky bubbles.
If you just look closely there, that is probably Sigma Octantis, is that what it's called? Is it just there?
Yes.
Right? And just off center there is Polaris, which, if you watch the actual full time lapse of it, you can't see it there, but it actually does go around a little bit on the actual original video. So what I did here,
Yeah.
I caught some of these star trails. One was my mate Jose. This is what I pinched off the internet. So as you can see, when the moon is on the Tropic of Cancer, it will appear to be rotating clockwise in the northern vortex or the northern vortex. As it gets southern declination and it gets to the equator, what you'll find is then when it's on that 90 degree rise 90 degrees, you'll notice that it will appear to go across the sky in a straight line. And this is when I caught this video here, and it is just slightly above the celestial equator. It's very difficult to catch the moon on the actual celestial equator because it travels north to south so fast. It literally goes from one side to the next like in overnight. So it's very difficult to actually get it. If you look just below it, you'll see like a star trail, and that one is probably closer to the celestial equator than the actual moon itself. But it gives you an idea of what I'm trying to say here. And then what you'll get, this is from my friend Jose in Portugal, and he caught the moon just slightly under, rotating in the southern vortex. If you can just take that back a little bit and play again. And as you can see, when it's below that celestial equator, when it's been picked up on that southern vortex, it will rotate the opposite direction, the same direction that they see it, that anybody who's observing any luminaries from south of the equator will see the stars go from right to left, and that's basically what that's doing. It's rotating the opposite direction, which a magnetic field would do that. You would get it rotate in the opposite direction. And here is basically that's the northern vortex. That's where the celestial equator will be, and that's where the southern vortex will be. That's just basically the analemma. You see.
Can I ask you something though, Dave? Just a question, right?
Yeah.
Somebody said they used a telescope when they were looking up at the stars at the telescope. Is it like without looking up at the stars, they just took the lens off of the telescope, and when they pointed it down the road, the lens was bent. Everything was bent in the lens, so it means everything in a telescope is bent on purpose. I'm just asking you, can the same thing happen with the camera because it's round?
Well, of course it is. All lenses are convex, aren't they? You know what I mean? It doesn't matter what lens it is, whether the camera inside the camera lens or if it's a telescope lens, your eyeballs. Like I said before, nearly every lens is convex. And I think Chris has already touched on it, that the only time you can actually see straight is when something's smack bang in front of your eyes, basically. So when you're observing any bright object from a distance, whether it's a fire or a star or whatever, it will always appear round. that you'll see it, regardless if it's a fire at 50 miles. What you'll just see a round little light. What will be flickering. It'll probably just look like a star if it was a big enough fire from far enough, because obviously you're looking through it through a giant lens, which is the atmosphere, and then you're looking through it with your own lenses. You know what I mean? A telescope has multi lenses inside it, and what it does, that's why if you shoot the moon through a telescope, it always looks like a sphere. But if you shoot the moon with a camera on a full moon, it doesn't look like a sphere at all. It's only the terminator edge what gives it that spherical effect. So that's basically why I think the stars rotate. And then basically I've just put there, so when the moon is above the celestial equator in the north, around the Tropic of Cancer, it is circling the northern vortex. When the moon passes the celestial equator, it will pick up on the ethereal currents on the opposing vortex. And when the moon is below the celestial equator, around the Tropic of Capricorn, it is circling in the opposite direction in the southern vortex. And just before I finish this, what I time-lapse the moon in the daytime once, to show you that this is when it's way below the celestial equator. So if you just check this out now, you'll see what I mean. It's actually looks like it's going away from us. Here you go, look. And that's because it's below that celestial equator on the southern vortex. You can see the arc it's made. It to us, when we're just looking at it in the sky, we can't see that trail, and it just looks like it's setting. But it's clearly, if you could overlay the sky time lapse now with the stars or a magnetic field, you'll see that it's basically following the actual pattern of the magnetic field.
Mm.
So I hope that explains a little bit of.
Yep, I hope that helped a bit in the chat room there, guys.
Yeah, and I want to thank Dave for all the hard work he does putting this together, this information. This is where we do our scientific research.
Thank you to Chris, we have to thank you to Dave, and we have to say thank you to Series.
Oh,
And
absolutely
you.
everyone. And Karen. Can't leave her out.
And Dave, that confirms exactly what I've got set up in the model to try to replicate all that stuff. If I take a look towards the south when I'm standing on the flat plane and rotate the stars, rotate the torus, then you end up with that would be looking south. And if I move the camera slightly, let's see, on the, say, towards the z-axis, just slightly, so I'm still trying to stay focused. So I'm just rotating the camera. This is perspective view. So if you're slightly east or west on your east-west line, and then you rotate the torus, then you'll see that now the arc, you'd see something rising and setting on the horizon, right? Say Venus or whatever in the south. Because it doesn't take much, like you said. The Polaris is offset. If you, the more east or west you're looking, there's a bit of perspective there, but it's not as much as they claim, right?
Yeah, exactly.
Right. Exactly what you see in the star trails. Yeah. And Steve, you mentioned Steve Torrance. He's got some great videos on that too, that shows how it warps the star trails.
Yes, like I say, if you ever get a chance, click on his channel and just look at some of the stuff he's done. I think he's using Cinema 4D, and he has done quite a lot of analemmas of different wandering stars. I think he did Jupiter, Saturn, Venus over about 100 years as well. So yeah. It's worth a look. Definitely worth a look. So when I finish putting this video together, hopefully I'll get done tonight, because my fiance and son have gone on holiday, left me on my own.
Oh.
I'm going to try and put it all together tonight. What I've done basically with my moon race video, because remember when I made my moon race video, I was trying to prove that the sun and moon were circling. That was my goal in that. Yeah, and I had to basically put my hands up and say, you know what, I'm wrong, and that's what I've done. But and that's what you have to do. You know what I mean? When you hit a brick wall, then you have to obviously look elsewhere, and that's exactly what I've done. And like Billy said, yeah, how could I shoot the moon and my mate Robbie Davison, who's 10,700 miles away, the following day in Tasmania, shoot the same moon? It's impossible. You know what I mean? It would be impossible unless that's projected towards me and projected towards him. That's the only way that we can both see that moon from being 10,700 miles apart. There's no other explanation for it.
That's right. Yeah. Yeah. The refraction. Yep. Just projects the image into a different perspective point. Yeah.
Yep, hence sodium fluoride. That's why they make you drink it.
just showing a picture of your map because the chat room were asking questions. I just want them to see that Antarctica is really high, and behind Russia it is really low, and that's water, and that's elevation in the water. So that's land and things closer to the surface, and it's looping. Oh, you're taking it off, series. Oh, change the picture. Series, do you want to explain a bit more about what they're seeing with your picture then?
Yeah, I'm trying to zoom in.
Thanks for that, Dave, by the way.
That's okay.
You
So
seem to be
David-
experimenting more now, don't you?
Say again, I missed that bit, sorry.
You seem to be experimenting more now.
Well, like I say, I'd commented on one of Jaren's video. I'm not scared to mention his name. Yeah, I'm sure you've seen the new video he put out. The 4-hour epic video was just put out, and I flicked through it. Obviously, I didn't see much 4 hours of it because I ain't got 4 hours spare. So I just flicked through section after section. I was looking for some of this proof of the circling sun, and all I got was Google Earth and like a simulation. So it wasn't really that much proof to me. If I'm honest, I was expecting some, and it didn't present anything in 4 hours.
And you got a copy of the map that I ran through the other night too with the flight pass. Yeah. Copy of the image.
Yes, when Jaren used that round map, that he used Chris's picture that he was using to show that it didn't work.
Yeah. So basically, I left a comment because I know that Jaren's seen my videos because he commented on it and said subbed. Then he asked the question, how much did the moon shrink when it was south? Because I know what it was getting at. It was referring to parallax. Obviously, objects when they're further away, they move slower, so it would take longer to get on my screen. Which I did take that into consideration because I learned a lot of mistakes, a lot of not mistakes, but a lot of things what I did in the first moon race, what I corrected in the second one. You know what I mean? I did actually learn from the first video, and I tried to get it right in the second video. There is a lot of things now that I'd probably change again, like I said. But I've done the video now, and it's out there. And I wasn't commenting on Jaren's post to try and promote my video because I didn't go on there. I just went on to ask a simple question: why you never mentioned the actual speed of the moon? Because that to me.
Prove it now, especially as you've done these experiments. You know, you're a real person who's done real experiments in your own time, and we're all very thankful.
Yeah, and like I say, it's I also messaged and tagged him on his Facebook post as well, with the same question. Does he believe on the circle model that the moon, when he heads from the equator to the Tropic of Capricorn, would need to speed up on an ever-expanding circle? Now, I'm sure you'll agree that it would have to speed up significantly.
What did he say?
Well, there's been no reply.
As well as the sun.
Yeah,
The sun would have to speed up too. So.
Yeah, the sun would have to speed up too, and like I'm sure you've seen Darren's post where he's posted the sun on December 21st somewhere in Argentina, where they get 17 hours of daylight. Which is
somehow both have been constant for 40-some thousand years or whatever long we've been watching them. Yeah.
Right, and we have similar time in north and south latitudes for the season for the summer solstice and winter solstice. So the sun is not speeding up and not slowing down. Okay, I don't know. You know, I'm sorry if
a lunar month has been 27.6 days for how many thousands of years?
Yeah.
Exactly.
Yeah, just remember the lunar cycle's 27.3 days, but the actual phases are 29.5 days. It's because the cycle's based on the sidereal day, which is 23 hours 56 minutes, and the phases are based on the solar day, which is 24 hours. That's why there is a difference, and that's why the moon appears at different positions in the sky at different times.
Yeah,
you know what I mean. The full moon.
That's the one thing I can't replicate that in my model, because I'd have to be able to rotate the moon and sun in on the east-west line, and then rotate the camera on the north-south, right, to make that work. So I can't do both at the same time. I can lock the sun and the moon together to get different angles of phases, but I can't rotate the other way. So.
Yes, it seems to be a system that no matter how hard or how you try and think how it works, there's always, you get 3 parts of the puzzle, but the final piece never fits. Then when you get that piece, another part of the puzzle doesn't fit, and it's constantly just trying to get these pieces to fit. You know what I mean? My brain, I fry my brain trying to think of it sometimes, just trying to imagine it, how it works in my head. And like I say, it's just a never-ending puzzle that I think like I say, you need to look at things like multi-dimensions for it to work, because it will not work observation and maths. It won't work. There's always something that doesn't work. I mean, they've been building the heliocentric model. They've had the top mathematicians and scientists building it for God knows how long, over 500 years, and they still can't get it right now. You know what I mean?
No.
Yeah. The maths work in principle.
You'll never be able to get a shadow on the North Pole from a lunar eclipse in a globe model. That's for sure. I can't do it. I tried for months. Can't do it. But I can in this one. I can do it. You just got to angle when the moon just angles slightly off the 5 degrees, and the sun is in a certain position and it angles in the opposite direction. You can cast a shadow on the north or south polar axis as far as you want, but you can't do that in the globe model. Impossible. That's what got me into this in the first place. Right?
Were you doing this kind of stuff before, like about a month ago, when we sort of clicked up with you proper? Were you doing this all the time, or is this something you've got back into now?
I've only been trying to do the 3D modeling of the actual system for about 3, maybe 4 months now. And at first I was like, okay, well, I was going to try and debunk the flat model, right? I was going to say, okay, well, I'll just model the solar system. I'd be able quick enough to do that scale, right? It's just balls on an axis and, rotate them in a circle. But then when I started looking at it, well, I couldn't get a shadow from the moon to the Earth. I had to either scale the moon way up or bring it way close. I was like, okay, well, that's one problem. And then I couldn't get a shadow on the North Pole either. So in order to get a shadow on the North Pole during a lunar eclipse, or a solar eclipse, you have to have the sun directly above the North Pole and the moon directly above the North Pole. And we know that never happens in supposedly in reality in the globe model, right? They're both restricted to 5 degrees inclination and 23 degrees tilt on the so-called solar system axis, right? The galactic axis.
Yeah, and that's all. The distances are all relevant to the sizes and the distances, isn't it?
Right.
That's
so
why.
Right.
Exactly.
So if you're restricted, I was restricted to that constraint, so I couldn't cast a shadow on the North Pole whatsoever. Right? It's impossible. Yeah. So then I was like, okay, well, now I got to put it all inside reel and do the toroidal thing, and that's how it works out. It works out perfect. So Dave, if you want any model shots and stuff as well, like I can line up a camera and say, okay, this is a 3D model. I'm from the inside looking out. This is the shot that Dave has done. I can put it on the map now. I should be able to.
Well, what I was thinking, Chris, I'm collating all this data from the moon by timing the meridian passing, the between days on the tropics, on the equator, it'd be good if you could just build, because what I want to do with this, I want to debunk the heliocentric model, and I want to try and build up a presentation for it. So what I was thinking, if you could build like a small scale model, don't have to be anything fancy, but just to show that the Earth and the Earth and the Moon on the heliocentric model with my actual readings, how it would work, you know what I mean, and then show the inconsistencies between the what's happening in reality and what they're saying is happening in the heliocentric model. If you understand what I'm saying.
Yeah, your actual location on the map, and then the perspective to the actual moon on that particular location in time.
Yeah.
Well, like I say, according to the heliocentric model, it speeds up when it's approaching perigee, then slows down. And it's doing the exact opposite. It's speeding up when it's heading from its closest point. You know what I mean?
Wonder, isn't that like what Venus is kind of doing in the actual back looping in the little looping, and then going the bigger loop around again? But then for the moon, kind of that it does the big circle, but when it goes in its own direction, it's actually lining up with its own speed, with the same speed, and then when it's going against the direction, it speeds up, or the other way around. But
it's difficult. Like I say, it speeds up when it leaves tropical Cancer to the equator, but on its way back from Capricorn, it stays at relative same speed, and that's what's puzzling me, because it's difficult to get your head around that, because
that one photo of the moon Analima cycle, what I saw, it occurs to me that indeed one side is actually kind of a straight line, and the other one is kind of looping backwards, and that you can see that the cycle is there, but it moves through the sky as well, in either east or west direction. I'm not sure from where to where it was taken, but on the photo, I can show the photo.
Yeah, we should be able to figure that out. It sounds like a sine wave. It sounds like it's traveling in a sine wave, which makes sense. Which would make sense, right? It's because as a sine wave, it would tend to appear that it's traveling at a certain speed, then it would speed up, and then slow down as it makes the arc, and then speed up again, as like doing in this snakes, you know, like a snake, right?
Yeah, because like I say, it makes sense to speed up when if you think about the northern vortex, for it to cover that distance up to the equator, it would need to speed up to stay at the relative speed, wouldn't it? And that's what's puzzling, like, because that it is doing that, and then when it picked up on that southern vortex, it's doing what it should do on there, because on the Analina, it would be slightly bigger in the south, I think. And
yeah,
bigger in the south. Okay.
Yeah, I think it is larger in the south. Yeah.
Actually, the what they made, but I wonder if we can actually make this kind of time lapse photo of how the trail goes. Probably the same way as the Sunday recording was, that you have to record a complete year, or at least a month, and then line up a time between the moons. It's actually line up in the Analima of the moon, and then you just move the Analima towards to the right or to the left. I'm not sure what the actual cycle is in this photo. To see that it's moving to the right.
you could probably do it on Stellarium. I don't think you could do it in reality, because rising 50 minutes later each day, I think you'd have to simulate it in some kind of application like Stellarium or something like that. To catch the moon in every single day like that, it's, you know what I mean, it's well, for me in the here where we are in the UK, it'd be nearly impossible, because like I say, the amount of clear skies we get these days is minimum. So I just have to work with what I've got. But I reckon you'll be able to do some kind of simulation with some kind of software or even Stellarium, which you may get this similar kind of effect. Like I say, if you look on the moon race video where I took snapshots on Stellarium, you can do it, and you could probably overlay the snapshots on top of each other to try and build up.
Yeah, you have to time your photos of the video. It's like you record a month of video, and out of that you actually line up the time of when the moon is there in its own cycle of the day in that sense. And you can actually measure the speed between the moon light, etc., of every day it goes there. Through all the timing of how you record it. And that you do for the particular cycle or even a whole year, and you have a complete presentation of how the analemma of the moon works.
That'd be good.
You could probably completely line up within its own bigger cycle, in that sense, of all the analemmas together.
I don't know if I could do it in the 3D day, but I do have a screenshot up there that's, I think is, I don't know if I can actually program it to do it though.
I'll be back in 10 seconds. Nip to the toilet.
Yeah, you need at least an angle. You can view the complete tropic part at least.
Well, yeah, the moon, what I have in here for the moon Taurus is the one that's highlighted there in gold. And it's basically the width of the tropics is how I set that, right? And the moon kind of follows that. And then
oh, a little angle even. Hey.
Yeah, so it kind of wobbles, and like you have to think of it as a gyroscope, right? So we're at the center where the force remains static,
Yeah.
and then these are the other 6 axes, like a static gyroscope. So then this would be the next wheel. Right, wheel within a wheel within a wheel, right? So each one, right, has its own axis,
yeah,
but they're offset, right?
Yeah,
And
and this for every
right.
planet system of planets and moon and sun.
Right. So that's where you get the analemma, right? So as they all kind of go around, they do a sort of a figure 8 wobble, right, relative to our perspective in the center, right? So each one has their own, and we stay basically vertical, looking at it sideways. In reality, yeah, because we're looking out through the bottom end of that apple shape, right? Where the target is where we're on this X target in the center. So that would be our magnetic field. And then the next one would be the moon, and then the next one's Venus and Mercury, right? All the way out until you get to the sun. From the end of,
And so it toroidal field, intoroidal field.
right. Yeah, it's a gyroscope. Yeah. A self-regulating and stabilizing gyroscope. And we're dead center. We're the center of mass because we have the most energy, right? All the energy coming from the field comes to us.
Repeat that to the chat room, can you, Chris?
Say again?
It's
That's why.
it's a gyroscope.
Yeah, that's why
it's a self-referencing and self-balancing gyroscope. So we're at the center of mass in the center on the plane the X-plane axis, right dead center, because we have the most mass. We're the most dense and stationary. Everything is relative to us, but it's still, each planet would wobble like if you imagine it as a gyroscope with 6 axes of motion, so all the way out to the sun, each planet is, the first, second, third. We're the first, 0 point stationary. Then the moon is the second, right, axis on this little tiny toroid gyroscope, and then another gyroscope is Venus, and then another gyroscope would be Mars, and so forth. And each one has a certain amount of latitude to be able to move, up and rock back and forth on the north-south, right? So and then as they do that, they go around in a circle, right? It just wobbles around like a figure 8, and we see it as an analemma in the sky, because each planet would be locked into a point somewhere here, rotating within this magnetic field.
Yeah.
Because if I light up Venus here, so Venus is out in this toroid, and it's locked within this circle, so it can't leave this magnetic field.
Yeah.
But it's on this path, right? So it's locked into this.
Itself.
Right.
But it causes the field.
Right. So
locked in the. Yeah.
Right. So Venus's magnetic field is huge, right? It's locked into this magnetic field. Is actually quite huge, but it can't get out of the donut in the middle, which causes an analemma, because if you rock this back and forth, right, then you would see an analemma, because I can actually might be able to do that here. Cursor to the center and rotate that on the Y. You see an analemma pattern, right? It's just doing that. Right. So now you see where, if you look at that through this Z axis, you're going to see a figure 8, right? Right. That's all it's doing. Right. And then the moon torus is way inside, and it's just doing the same thing, only it's closer to us, right? So it doesn't wobble as much because it's not as big a path. Yeah. And this one would be, I think this might be Venus, Mars, one of them. But I just programmed them in there based on their distances, approximately.
I wonder if there is either the flower of life grid tying into these particular distances as well.
It is, yeah, because if you look at it's a frequency, right? So the first one is like 1/3 ratio.
I only have the 2-dimensional plane yet, but that's actually the ground on where the whole flower of life grid works, also in 3-dimensional sense. So I have to build up upwards in how that actually is built up in the structure of all these toroidal layers. It's layering, so far as you.
Right. So our torus is really small, right? We have our own, and we're stationary at the plane, and we have our own magnetic field, north-south.
Yeah.
And then the moon is right there, right in the moon's field, is this one. So the moon can't leave that circle of rotation. And the width of that circle, where it can flop around, it can rock around in here, right, in the magnetic field. But the width of this is the same distance as the Tropic of Cancer to Capricorn.
This toroidal field, how you see it, is actually how you also oversee the 5th-dimensional looping. In that this 4th dimensional is that little circle on top of and the bottom of that particular circle. That circle is the 4th dimension, but the 5th dimensional is the donut.
And that's why we only see the one face of the moon always facing us, is because the moon's north-south pole is actually on this outer part of the toroid. Its face is in here, and it's locked to our polarity, which is inside, right? that make sense? Right,
Right,
the moon is locked in here, facing us, and the moon's
in that circle. Yeah.
north south pole is here, right? So this is the Birkeland current. So the Birkeland current is going north south this way, and then if I rotate it around and then rotate the whole thing, then the moon will make an analemma, right?
Yeah.
You'll see it kind of wobble, right? So there's the analemma shape, and that's what you would observe in the sky. It's locked into one of those polarities, but it's only locked into one of these, right? So it's going to create this analemma back and forth like that. You would observe as a crossing figure 8, because it'll just repeat.
Calculating how long the cycle takes in the 4th dimensional sense, and then in the 5th dimensional donut as well, and spread that out as a complete line set in how the moon, or the moon to begin with, I guess, and in how the moon actually works, and then animate that as an analemma projection in the sky and see how that actually lines up with reality.
Yep. And there's the 4 pillars if you look at it. So there's 1, 2, 3, 4, right, across. So I think it should be pretty easy. Dave can give me some data and I can put the coordinates down way down in there, you know, because we're way in here. Our little reality down there.
Yeah.
On that plane, right? So I can put a coordinate down on the z-axis and then take a camera shot. I can just angle the camera from the equator up at, you know, the 2 to the 45-degree incline, and take a shot of the moon and see where you can follow it all the way around. I think it's kind of a cozy setup, really. It's like babies in a carriage inside an egg.
Yeah.
Right? Just rocking back and forth, you know.
Zoom out, zoom out, zoom out. That's the main toroidal field then.
Yeah. And then this is our little neck of the woods down in here. So I mean, we're in the cradle, right? So if you're dead center, then, you know, the only motion that would ever happen in here would just be a slight, you know, just rocking at the center of gravity, right? It's the center of the pendulum. Everything moves around it.
Kind of, we are the space of the anti-space in the magnet.
Dead center in the nucleus of a magnet, yeah. Because that's where all the torque would focus. Like all that torque would all be into here and then come out the other side in the other direction, right? Because it's going to go counterclockwise one way and clockwise going out the other end. That's just the way torque works, right? It's counterspatial. So all the torque would come in this direction to the center and then go back out this direction and just do a figure 8 in a spinning motion. Right?
Yeah.
Can I just say that we've been going for 3.5 hours now?
Yeah.
We've got to be a little bit more stricter on the time, otherwise me and Sirius are sitting here for 6-7 hours a day.
Seems like a lotus flower.
Lotus flower, yeah.
Left side.
Yeah. Well, there's the analemmas too. So I'm just comparing the sides, just the angles. So if you look at, you know, straight on from the top or the front, doesn't matter. I can just go to a front view. Yeah. Or then the side view. So from the front view, you get the flower, lotus flower. From the side view, you end up with the analemma, right? And because it's got a bit of a tilt to it, like I said, you would see a larger analemma in the south than you would in the north. It'd be a tighter pattern. That's all. It's just perspective. Yeah.
Wow. Asking you, Chris, do you know what's on the outside of that? Just asking, or that's as far as you can go so far.
Well,
Asking.
Well, we end up in the.
Is it all like that for?
Yeah, I think it just repeats. If we end up just in the plasma field of whatever the sun is contained in, and all the light comes into here, then who knows after that? Plasma and light.
There's a
Energy.
complete shift as well to link up. And this is only part of the whole chakra body system of probably 49 of complete 7 chakra system. No.
Yeah.
I don't know how big it goes in body sizes and awarenesses, and eventually the complete universe as a universe next to a multiverse of several other focal points in the centers. As where we are, same thing.
Can I ask you something, Series? Or Chris was saying that maybe in the past they got mistaken thinking we were a ball. But how could you mistake all this? You've understood it. You know, they did understand stuff. So how come there was a big gap to here?
Both the Chinese and the Egyptians believed that the Earth was a flat, stationary square.
Mm.
Yeah, it was only the ancient Greeks who actually thought it was a ball.
Mm.
Yeah, and I see, you know, when I start rendering images in this, I see all kinds of like the Chinese temples that have like the curved tops on them. Right, so it's like an archway that goes up like a half moon, and then the pillars come down. Well, when you start rendering it and you zoom back far enough, you'll see that in the sky. That's how the sky actually makes that dark shape, and it's the same thing with the boat in the Egyptian. Right, when you render out the images, you'll see the boat and then the stars over the top. Yeah, it's all there. But you have, and I don't know, they must have spent a lot of time watching the skies to come up with that kind of understanding of it, like by hand without computers. I mean, it's taken me months to figure, you know, to get this kind of stuff straightened out. And especially to know that light goes in one direction and reflects backwards, because they would have had to know that, right?
Did you get that, guys? Even the light's different than what we thought.
Well, it's not only that, we can't even study the stars like the ancients did. They had crystal clear skies. They had no luminescence from the city lights and stuff like that. So they had a really nice visual, even with the naked eye. I mean, they, you know, later on they had some primitive optics with telescopes and binoculars but to map all these star patterns out and stuff by hand, like Chris said, wow, what an undertaking. You know?
Yeah, I looked up there and I just thought, I need to be able to, I can't map that out. There's too many.
Yeah, not only that, you've got that many chemtrails in the sky night after night after night. You can't hardly see anything anyway. Like I say, it has been a clear day today, but the sky's been spoiled by chemtrails. And it's passed over up to the night time. And like I say, it's not been a cloudy day at all today. It's been clear. It's been hot, and it's been muggy and horrible because it's all been chemtrail.
No, late enough, I had enough sun today. Normal clouds.
You know, the funny part is when I try to think about it, and I'm trying to visualize it in my head and draw the model, the first thing I think of is, okay, how would a hamster in a ball see this from the inside out? And that's exactly kind of what it is. If you put a hamster inside the center of a ball and then put 6 or 7 more of them outside of it, and he's running around inside, right? That's exactly the perspective to think about. You got to think about it from the inside of a fourth-dimensional object, right?
Yeah, kind of a double ball, because you're walking in one, but your head is also the top of the bottom one.
Yeah.
So wait a minute. The longer nights come when the days are shorter here.
Yep.
With the sun is closer. So that would make sense, wouldn't it, to the longer nights? The higher it goes, the more lighter we have here in the UK. I'm talking about.
Yes.
Yeah, well, technically speaking, yeah, the closer the sun came to the backside, right, then the focal length of the shadow is going to change, because you got to think about the shadow, not the light. So if you have a ball or any object, and you bring the light from behind it, right, then the focal length, so then the darkness becomes shorter, right?
I wonder what is the ratio between the fourth dimensional circle and the fifth dimensional toroid donut. What is that particular ratio? Because the square is one light, and that is that ratio of the fourth dimension. The size of one for the fourth dimension. What is then the fifth dimension?
Well,
That complete loop.
well, I'm pretty sure you could figure it out if you knew. Let me think about it. If you know the height of the dome where the shadow or the light appears, then you could figure out the distance based on the diameter of the shadow to the object from behind, if that makes any sense. Right. Then you can calculate the cone of the cone shadow based on what you can see. So if the shadow is 72 miles, then so the light object is probably 72,000 miles in the other direction, or whatever. Yeah. You could figure it out, though. That would take some time.
It's changed, Dave, hasn't it, Dave? To any, like even 6 months ago, what you thought about where we live, it's all changed, hasn't it?
Yeah, it's looking good. I think
Right,
Siri needs to put a bit more diesel in his computer, though. It's slowing down a bit.
It's believe what we're going to say.
See, AMD coming out with the 16 or 32 core this summer somewhere.
Yeah, definitely need a bit more processing power, but it's looking good.
Did you see the? Were you watching there when I did the little gyro demo thing there, Dave?
Yes, I was. Yeah.
Yeah. Okay, so that makes sense. Yeah.
Yeah, that's amazing. We're actually living in a gyroscope. Oh my goodness.
Exactly. Always staying flat.
Yeah.
Wow.
Mm. And the night's caused by the sun.
Right, because you can see the analemma, and if you just kind of, I'll rotate it slower this time so people can see it.
Isn't that something how mankind just discovered what their natural reality was and imitated our reality? I mean, the man was the one who invented the gyroscope to begin with and figured it out. And you see, left on your own fruition, people would have figured things out on their own. That's why they didn't want you figuring it out. That's why they programmed you not to figure it out. And they kept all this information of our ancestors and the true scientists all occult and all hidden. Because, with this type of knowledge, they could basically control societies. And when they can control this society, that society, then it became a one world collective where all these scientists and leaders are all in on it. And they keep the rest of the world in the dark. And they put on these big stage performances, such as NASA, with the green screen and the wires and the hairspray and everything, just to keep people occupied. It's truly sad that these people would go to that kind of length, and they do it as a job, I guess. I mean, for earthly gains, and basically lie to people with a straight face. And they say, I have, right,
day in, day out, putting it on the news.
Right, guys, I'm going to shoot because I want to get cracking on with this video. But it's been good talking to you all and learning a little bit more each day.
Dave, looking forward to it, buddy. I appreciate
Yeah,
all
like I
of
say, it's only going to be a quick video. I'm just going to basically show the movements of Polaris and just basically put it out there and say, right, what's your answer to this then? Because according to the circle model, I'm sure I've just read in the Robotham book that it is fixed. So, like I say,
Yes,
he only had a pipe where he faced to Polaris. I think it was like a steel pipe where he fixed in his backyard, and he stuck his eye through it and he viewed Polaris. But things have moved on since 1865.
right.
So we've got modern cameras now what can zoom right in on it. And like I say, I was quite surprised when I actually picked it up last night, because it is very, very difficult. You have to use the eyepiece to pick it up with. You can't pick it up on the screen. It's just impossible because of the light. And you got, like I say, where I live, you do get quite a lot of light pollution. I turned all the lights off in the house, but like I say, I've caught it, and I'm gonna hopefully finish the video tonight and put it out tomorrow, showing that Polaris clearly is moving. Because I've also just been looking at Stellarium, and it moves on Stellarium as well. You can zoom right in on Stellarium, and you can watch it drifting away on Stellarium. So, but it's been good talking to you all, and I'm gonna have to shoot.
Okay, Dave.
David James's versions of the moving Polaris. He put it out a few months ago.
I'm not sure if I had. I got the idea from Wide Awake. I know that he's done a few videos on it.
Yeah.
He gave me a few tips on how
David
to do it as well.
Ask David James.
Yeah, I will do. Right, I'm going to shoot because I'm going to go get some
Thank you,
sleep.
David. Thank you,
Right.
Dave.
There's Dave.
Yes, thank you, Dave. Yeah.
All right, I'll see you all soon.
See you next time.
Bye-bye.
Sharing.
Bye.
On that note, guys, it's now 1 o'clock. We've been going for nearly 4 hours.
You folks have yourselves a good night. Yeah.
Yeah, do you mind, chat room? We've been going for 4 hours now. We're back tomorrow at 8:30 with allegedly Dave, the Morgile, and Oliver Ludlow. Action-packed evening tomorrow. Hello, Billy.
Just getting ready for the big hug.
Oh, I see. Thank you. Yeah, Chris, you've got to come on. Patricia, series. We have to have a group hug. Hey, Patricia. Is Patricia there? Anyway, group hug. Everybody, thank you so much for watching. We're back tomorrow at 8:30, and thank you for everybody for listening in for all this time if you stayed. See you tomorrow night. See you tomorrow.
Yep. Till tomorrow. Take care, everyone. Have a good night.
Thank you.